Great. Hi, everyone. Thank you for joining us for our sessions today, the 10-minute presentation with the honorary 5-minute presentation as well, mixed in, first day of the research conference. So we're going to have it the same format for most of the presentations you'll be at today. So we have all the presentations and then questions at the end where you can ask any of the presenters who've just presented questions. Oh, last one coming in. So the first up, we have Noran, if you want to come up, and I will put your presentation up. I will set a timer, but give you a bit of a warning as well, so hopefully it'll be okay. Hopefully that will be okay for you, and hopefully it should work.
Yeah, thank you.
The mics and the camera safe.
So okay, but should I stand here?
Yeah. That'd be great.
Oh,
so come around. I thought about that.
Yeah. Hi, it's me, Nuran. I'm happy that we started just after lunch, so we all energy now. So this is my PhD project. I'm under supervision with Dr. Serge. This is about how to build a system for Arabic text simplification. So basically what we are doing is to try to simplify the complex Arabic sentences into a simple ones. So I'm going to just quickly going through the background, what are the corpus and tools that we use in this project, the methodology, and then what we finally reached. So first, what is text simplification? As I said, it's just to simplify the text, but we need to bear in mind the meaning, just the meaning, and also the original information or the main idea that we need to convey through this text. And what is the aim of this is to convert. Why we are doing this, because it is helpful for students, for second language learners, basically, also for people who have intellectual disabilities. So, and also it also use it as a pre-process for machine translation, for example. And how did we do this? This is through we are going to explain through the methodology. So we did 2 different systems using a classification approach and generative approach. So this is a simple sentence away from Arabic. For example, when you have staring in English, so we wanted to transform it to, for example, looking. Of course, it is not the exact same meaning, but it does convey the same information. Okay. Basically, the main thing that we consider is to do lexical simplification. So we have different types of simplification, but we're focusing on lexical simplification now. We have 4 main steps to do lexical simplification. The main step is to first identify the complex word, and then generate the synonyms or the substitution of this word. This is called substitution generation, and then ranking this substitution to which is according to that context where the words appear, and then we select the best one out of, for example, 10 substitutions. Yeah. According to my corpus, of the corpus that we use around 3,000 sentences, parallel sentence. One of it is complex, and the other part is the simple parallel version of this complex sentence. This was collected from Sakot Bamboo novel. It is an Arabic novel which had a different simple version of it for second language learner. We selected of this, and then this is the operations that happen in the corpus. Most of the corpus was just rewriting the same sentence, and some of them were just dropping some sentences. And we are interested in this to which part we would replace in the sentence or add new words. Going through the whole tools that we used in the system. So this is the Madamira. This is a morphological analyzer for Arabic and Python, scikit-learn, of course, and PERT T5. I'm not sure if you're all familiar with this, but some of them are transformers, the new language modeling, as just said before, the transformers or language modeling, and some of them are specified for Arabic, and we write the code with Python. So this is assembled. Yes, we also needed to have a pipeline for readability, so for how it is complex, because so it is easy or very complex or very complex. So we have this criteria to identify the levels of complexity. It's the CIFR levels. It's Common European Framework for the Language Proficiency reference. So we had 5 levels, but we use in our corpus the main 3 levels. It's A, B, or C. So it's easy, bit moderate, and then complex. Yeah, and then yes, this is another part. Before we doing the simplification, we needed to know which sentences we need to simplify first, because not all the sentences in effect could be simplified or needed to be simplified. So sometimes when you simplify already a simple sentence, we get more just like a nonsense sentence. So what we needed to do first is to identify the complex sentence and then identify the complex words in this sentence and then simplify them. So that's why we needed to build this readability classifier before doing the simplification. And then we also built we had 2 different classifiers, but the first one with the binary classifier, which says it is complex or not. So easy or complex. Using Arabic PERT, and the F1 measure was around 0.94. And if anyone interested in this, I also added the link for the classifier, for the paper for the classifier, and also the classified corpus using this classifier. Coming back to the actual system, that after doing the classification, we know now which sentences needed to simplify and where exactly the words. To know where exactly the word, we had 2 different systems. Classifier or the generative approach, classification approach using, can you remember the lexicon simplification steps? We have 4 steps. So for this classification, what we did, we using each step as a separate step. We used first identify, and then identify the complex word, and then define the list that could substitute this word, and then rank this list, and then select. Using PERT or fast text, this is how we did it. And for the generative approach, we used another version of the language modeling, which is T5, which is text-to-text generation technique, which just we could view it as a translation technique. So from complex sentence to simple sentence, and then we had this T5 model in between to transfer between these. That's how we combine all the 4 steps into one single step. Using using the T5. This is also just to go through an example. This is how PERT take the sentence. It's 2 sentences, and then we had the word that we are identified already as a complex, as a masked word. And then what PERT does, it does the list of the word that could substitute this word based on this context. Okay, and it also rank it according to PERT. But what we also did is to having fast text is a word embedding model rather than also the contextual model PERT, and also generate the words according to fast text and realign the PERT model also of the PERT list according to the fast text, and see between both which is the best substitute to this word. So in English example, so this word means obligatory, but the easiest word is necessity. So this is how we did. Rather than using the word obligatory, we use the word necessity. Yes, so the generative model, as I said, using the T5 model, just like a machine translation model. So we had the model in between, we had 2 models. Using MT5, so also we did use the same corpus, the same thing, all all the same procedures, just different methods just using, rather than having the 4 steps, having also in one step. The contributions are what we achieved, that we have now a system actually to do the simplification, either by the lexicon simplification, the classification, or generative. So we have 2 different models now running. The F1 measure for the first one is 0.97. The F measure for the generative approach is 0.70. However, some of the sentences in the generative model is sometimes much more simpler than the one that we had already on the gold standard data, or the main data that we use. Yeah, some of the limitations that we have already also did that we will still need to find different solutions to find the complex words in the sentence. So sometimes it's misfinding the complex word, and also we have this repetition phrases according to the generative approach. Sometimes it's repeat the sentences or repeat parts of the sentences rather than having new version. Yes, but of course we prove that the word embedding and third could be used to do the simplification. Yeah, so this is how we would improve our system, is to, of course, to have, if we had a bigger corpus, a bigger parallel corpus, that would of course work. The second thing, that we can have also a post-handler rule for the generative approach that would eliminate the errors that come from the generative approach. Yeah, or also the adding semantic similarity model to make sure that the new sentence and the old sentence is closely related to each other.
Thank you, Laura. And now we have Oliver up. That's the right one. Yes.
Yeah, fantastic. Thank you. Where do you want me to? Where's it best to stand?
Wherever you want to stand, I'll make it work. Should be able to advance it.
Awesome. Okay, thank you very much. So good afternoon, everybody. I'm Oliver. I'm a final year PhD student in computational chemistry, which I appreciate represents a bit of a shift in field relative to machine learning and language processing. So computational chemistry is about simulating the outcome of a chemical reaction. So can you perform a chemical reaction on a computer instead of doing it in a laboratory, such that you can then guide the design, experimental design, and the design of these therapies. So my research focuses on mucoid Pseudomonas aeruginosa biofilm matrices of small in the lungs of cystic fibrosis patients. And so these biofilm matrices are very complex chemical niches. So we've got bacteria, which are the green balls, embedded in this kind of scaffold of extracellular molecules and ions. And so the idea is, can we use computer simulation to predict the interactions that stabilize these biofilm matrices and thus make them chronic and difficult to remove through antibiotic therapy? But also, can we use simulation to unpick the molecular interactions that allow molecules to move through this matrix? So, for example, signaling molecules, which are these glowing little balls. So can we understand how signaling molecules pass between bacteria through the matrix, and then use that kind of information to develop new pharmaceutical agents that can penetrate the matrix and clear these infections in vivo? So to simulate how two molecules interact, it's quite simple actually. You just got to collide the molecules together, and then you've got to evaluate the energy of that interaction. So you can collide the molecules together using Newtonian mechanics, and then you can evaluate the stability of that new complex using quantum mechanics. And so for many large n particle systems, you're going to need to kind of solve Newton's equations for every particle in the system, and then compute the solution to the Schrödinger equation for a lot of particles. And that's very, very difficult to do. And hence, this is why we need high performance computers, because we can parallelize those calculations across loads of computing cores. And so, as I mentioned, the idea is, can we look for kind of therapeutically relevant molecular interactions, which can assist future drug designers in the design of novel antimicrobials that can eradicate these matrices. So these are just a couple of snippets of the main results from my PhD research. We firstly identified that calcium ions, which are quite elevated in cystic fibrosis film, contribute to chronic infection through forming these tight, electrostatically stabilized matrices. And we also use simulation to understand the morphology of these matrices, kind of in under physiological conditions. And then we wanted to understand how similar molecules move in the matrix. And what we understood is that electrostatic interactions are what drive kind of EPS capture, whereas Van der Waals interactions allow a molecule to glide through the matrix and actually exploit water channels in the matrix. So if you're looking to design new therapeutic agents, they should potentially not exploit electrostatic interactions and try and only exploit maybe solvents position of Van der Waals interactions. And so that brings me to the end. So thank you very much. Yeah.
And next up, we have Anju. Yes, that's the one.
Hi everyone, it's glad to have the chance to present our recent work. My supervisor, together with my supervisor David and Tony, exploring the GLAD model for human action effect prediction. We know that our task is human action effect prediction, but when it comes to human actions, the most common task that we can see about action recognition that's given an action video segments, we predict what's the action, and action anticipation that's given a video segmentation about the previous scenes, we predict what's the next action. But here we're introducing a new task that's human action effect prediction. Let's see our definition of the task. That's given an image depicting the start world state of the action and the linguistic description of the action. We need to generate a new image that depicting the world state. That's what will happen after the action. For example, here the action is crack egg, and we give the start stage and the descriptions after crack egg what will happen, and we will generate a new image depicting the end state. That will be quite useful for robotics. And here, when it comes to action relevant data set, we can see that they can be categorized into two parts. That the third person video data set and first person video data set. You can see that the third person data we listed here, they're about human actions, climbing, walking, dancing at all, and they will show the human bodies here. But for the first person video data set, they're about the human manipulating objects and about object state changes. And the two data sets we listed here are about the preparing meals in the kitchen. And here for our experiments, we use the application data set since it's of high quality and it has 100 hours of records. So this is a large data set. Besides the model we use, the GLAD model, it's the public version is trained on a filtered data set that has filtered all the human body relevant images. So it may have poor performance about the human body predictions, but for the hand movement and object prediction, that's fine. And here we give a list of the image synthesized models development. We know that the generative adversarial networks has gained a lot of attention since its introduction in 2014. And the variation autoencoders, which was introduced at the same time, has increased popularity in recent years. And its following researches include VQVAE2 and DALI-1. And the diffusion model, we see that from 2020, it has gained a lot of attention and it has achieved really high performance on image synthesis. And in 2021, the paper, the diffusion model beat scans in image synthesis. And this year, the large-scale models, GLAD model, and the DALI2 and Imagine, they are all based on the diffusion models. And here for our research, we adopted the GLAD model. Here, things you can see here for GLAD model, it has two functions. First is it can do text to image. Given a text description, it will generate an image that depicting the linguistic description. And another one we are interested in is the inpainting mode, that given a masked image and a linguistic description about the something that you want, it will generate a new image depicting the linguistic and the image. So that's why we adopting GLAD. Since our input are images and the text. And here, to use it in our task, that the human action effect prediction, what we do here, the application that for each action, we will have a video segment. And for that video segment, we will take the first frame at the start world state and the end state. For example, it's at chicken. The final state will be the label image that the ground truth. The thing for the GLAD model, the two kinds of inputs, first the image, and then is the text description. For the start image, we will give it a mask. Let the masked image be the visual input of the GLAD model. And for the text inputs, we know that for action, usually the most common available text description are the verb and noun, this phrase as shown here. But we want to generate the description that contain more information. What we do here, we use the few-shot learner GPT-3 to generate the exact descriptions about action. For example, here after add chicken, there are no chicken in the pot, and we given these two inputs that the GLAD model generates the output. The key components here, first for the visual input is the mask setting. The mask setting, we consider the following three settings. First is the fixed mask. It's the easiest setting. We will set the manipulation area and the object state changes area to be the mask area, and the background, we will leave it unmasked. The other one is the masked RCN segmentation region. We will segment the objects and the hands to let the model change those areas. And the final mask setting we consider is the advanced RCN, and the hand and object detection area. It will detect the left hand, right hand, and the manipulated objects. The key step here for our method is the text prompt that the way we said previously, that we will generate from the verb noun phrase to get the action effect description. What we do here is that we use the prompt engineering. For GPT-3, we give it the task description that it predict the action effects and give it a few examples, and for the actions that without effect descriptions, let it generate. And so here we list the three action examples as we see the results. Here for these three generation results, we are with the textual input that generated from GPT-3 after add chicken, there are no chicken in the pot. You can see that if the input is only add chicken, for some examples, it doesn't contain the information that chicken in the pot, but for these three generations, all chickens are in the pot. And the best performance appears in the segmentation mask. That things with segmentation mask, it contains more information about the background area. Well, for fixed mask, you can see that there are no chicken in the pot. Yes, it meets the requirement, but the generated chicken area is too large. It can't take enough information about the background. But for this one, it can take consideration of the chopping board and the potato, some details. And this example is the cut apple. Also, the best performance appears here, the segmentation mask with the textual descriptions. After cut apple, the apple is cut in half with a knife. You can see the cutted apple and also the hand and the manipulated environment. And here is another example about to remove lead. The best performance is here with this text description after remove lid is no longer covering the object. It can show, although the shape is not perfect, it's because the segmentation area, you see that the shape is not totally round with the port shape, but you can see that the model is trying to remove the lid. And here we also show some failure cases. For example, here the turn on LED. But this action is trying to change the brightness of the environment rather than certain area. So here it even though we detect the moving hand, but it's changing the whole image, the brightness, so it doesn't work here. And another example, switch cupboard. You can see for the segmentation networks, it's trying to segment some objects in the cupboard rather than whole cupboard. So how to let the mask to be the area that we want is another problem. And here, these two examples here, cut carrot and the pure garlic. There are new generated pieces. So the originally detected area, it may not meet needs since the newly generated the carrots into pieces, it can't hold so much large area. So that's a problem. In our future work, there are three directions that we can work on to improve the performance. First is the matrix evaluation, and then we will fine-tune the GLAD model since previously it's application of this model. Now in the following work, we can fine-tune the GLAD model using a specialized data set. And the last part of the work is that we are trying to avoid the use of mask, since we can see some instances the masks are necessary, since it prevents us see the whole state of the environment. So that's all of the work. Thank you.
So our next speaker is online. It is in. I hope you can hear us okay. If you can, please do share your slides. This is great because this isn't me. Yeah, that seems to be working. We can't hear you though.
Yeah, hello.
Great, wonderful. We can see you, we can hear you, all is well.
Okay, that's perfect. So, hello everyone. I'd like first of all to thank the organizer for this opportunity to present my work. I am Ibtisam Al-Shamari, a second-year PhD student at the School of Computing. The title of my presentation is Integrating Islamic Religious Knowledge from a Heterogeneous Format to an RDF Model. So, this talk is organized in the following way: an introduction of this study, including an overview of the Holy Quran, the aim of this study, what datasets are used in this experiment. Then I'll explain in detail the proposed method and results. Finally, our analysis, conclusion, and references. Well, Islamic knowledge has naturally been interesting for Muslim scholars, especially the knowledge of the Holy Quran, because it's the primary source in Islam. So what is Quran? Quran, or Muslims believe that Quran is like the God's word that's transmitted to Prophet Muhammad over the 23 years. As you can see on the screen, Quran consists of 30 divisions, 114 chapters, and subdivided into 6,236 verses. Thus, linguists and religious scholars have annotated and segmented the Quran text in different or various representations and formats. So we have different resources and formats. We need to unify these resources in or to an RDF model. What RDF model is? RDF is an acronym of Resource Description Framework that can store or represent the semantic web information. Now I'd like to focus on the objective of this study. As I mentioned earlier, we have different Quranic resources in different formats, so we need to link them together. To be more precise, we link the morphological segmentation part for each word from the QAC segment corpus to the word class or concept in Hakum ontology in both Arabic and Buckwalter forms. So what the Buckwalter forms mean? Actually, it's a computer-readable orthographic transliteration technique that uses ASCII characters to represent the Arabic text for non-Arabic researchers or academics. Our dataset are Hakum ontology and QAC segment corpus. Both are accessible and downloadable. So we choose these two data sets, and the difference between them, Hakum ontology has the essential or the main resources of the Holy Quran, such as the chapter names or the chapter's names, verses, and the description for each verse. The QAC segment corpus, it has the morphological segmentation part for each word of the Holy Quran. So this is our method. Actually, it has different steps, and we'll explain them on the following slides. So the first step is the data preparation. First, Hakum ontology, we determine the missing part in this ontology, which is the segmentation part for each word. The other one, which is QAC segment corpus, actually it's an like JSON format. We convert it to the CSV file in order to extract the class and the classes and the data properties names. Then we use the RDF mapping language, which is the main tool in our experiment. This tool actually used to map the heterogeneous format to an RDF model. However, what's the RML? The consortium of the World Wide Web created an RML to map or to map the data structures and serialization, for example, CSV, XML, and JSON files to an RDF. In our experiment, as you can see in this figure, we actually tried to map the Hakum classes with the columns in that CSV file, which is the CSV file for the QIC segment corpus. Then, or the last tool, which is the SDM RDF Visor, which is an interpreter or mapping rule interpreter to transform the unstructured data to an RDF. And as you can see here, we transformed the turtle file that obtained from the previous step to be uploaded to a Protégé editor to get our integrated ontology. Now, this is our result. We used the Protégé editor in order to show the statistical measures for both Hakum ontology and integrated ontology. We can see here, or I'd like to highlight and draw your attention to the axiom number. We can see on the integrated ontology is becoming more than 2 million. Also, the size for the integrated ontology increased by over 13,000. We then finalized the first chapter for the Quran, and we can see each segment for each word is linked to the word concept correctly. Then we evaluate our methodology by using the Apache Genophosic Sparkle query. As you can see in this figure, which is a Sparkle query to generate the Arabic segmentation part, and this is the result. While this slide explains the Backwalter segmentation for each word. Finally, our analysis, when we used the Protege editor, we faced a problem with it because it has a problem with the data set size, because that we increased the maximum memory allocation pool for Java virtual machine to improve its performance in order to extract the Arabic text correctly. It's also time consuming because it takes long time to generate the Arabic text. We also faced an issue with the Sparkle query because it doesn't work through a Protege editor, because that we use Apache Genophosic because it can handle and work with large scale ontologies and knowledge bases. So we can conclude our proposed framework integrated the chosen data set sufficiently. So this is our references. Thank you for your attention, and if you have any questions, I'll be happy to answer them.
Great, thank you. And the last talk we have is by Menwa. They're unable to join us in person, so they have sent a recording for us all to watch. So in which case, if you do have questions, you would have to probably email them. I will make sure I share with sound. Hoping everyone could.
Hi everyone, and welcome to my presentation on deep learning of semantic similarity in the Quran. My name is Minwal Shamari, a fourth-year PhD student in the School of Computing at Leeds University. Studying the semantic similarity in the Quran can facilitate extracting meaning and concepts and revealing the intrinsic structure behind the Holy Book that the manual investigation couldn't have uncovered. This study presents a computational approach towards learning the semantic relations between the verses of the Quran. Recently, the NLP community has witnessed the release of powerful development which set state-of-the-art results for various NLP tasks, including the semantic textual similarity. Intelligent ideas have come out, providing immense solutions for challenging NLP tasks, ranging from Elmo, transformers, BERT, and the whole wonders of a pre-trained language models and the concept of transfer learning. Hence, this research leverages the power of such models to uncover overlooked places in the Quran by digging the secret of the semantic inherent in this book. The semantic similarity in the Quran. It is an aspect of the uniqueness of the Holy Book and a sign of its eloquence. Perhaps one of the essential things that draw the reader's attention to this text is the semantic similarity between its passages. If two documents are semantically similar and describe the same concept, we can call them similar or related. The task in the Quran is challenging, as the degree of relatedness between the Quran verses varies greatly. Although there are instances where lexical matching is evident between the terms in a pair of related verses, the majority of instances require deep semantic analysis, and domain knowledge in order to relate the two texts in the pair. Also, the scattering of a particular concept in different places within the sacred text. Here I show examples from Qasim corpus that depicts the semantic similarity in the Quran. Each row contains a pair of verses that are similar or related. Reading through the examples can tell us that they share a common concept or theme. Qasim corpus was created from the original Quranic text where semantically similar or related verses are linked together. Here are other similar examples that were compiled manually by scholars, and we can notice the variety in the structure and that capturing the similarity occurs at different levels. It could be word overlapping sometimes, and sometimes it is more deeper than that and gets challenging. Analyzing the structure of the verse through its context is one clue that aids in its understanding. That is one approach scholars have used to relate text within the Quran manually. On that, therefore, we use computational model to create contextualized representations for the Quranic text that capture the syntactic and semantic properties of the text. Hence, we propose a Siamese transformer-based architecture for pairwise semantic similarity detection in the Quran. We exploit Arabic pre-trained contextual representations to derive semantically meaningful verse embeddings. We then fine-tune the twin transformers networks on a semantic similarity dataset drawn from the Quran. We have here two Siamese transformer networks. Each process one of the verses in a given pair. Each transformer network is composed of a transformer layer and a pooling layer. We define Arapert version 2 as the embedding layer that produces contextualized word embeddings for all input tokens in my text. We then define a pooling layer to derive fixed size output representation. We use mean pooling. Next, we average all contextualized word embeddings produced at the transformer layer to generate the sentence embeddings. Finally, we fine-tune the pre-trained model using our training dataset. When fine-tuning on a semantic similarity dataset, a regression objective function is used, where the cosine similarity between two sentence embeddings, verse 1 and verse 2, is calculated, and mean squared error loss is used as the loss function. Here I will talk about the main things in the experiment. First, the data. I created a data set that contains pairs of verses from the Quran with binary labels for semantic similarity. I used a popular resource that provides pairs of similar verses from the Quran, which is Qasim, the one we mentioned before. I imported the related pairs from Qasim. I tried different combinations of pairs given their degree of relevance when training my model. Non-related pairs were randomly generated to be not in Qasim. Then I split the data into training, validation, and test sets. I experimented with the non-segmented Arapert model that were pre-trained for the Arabic language, and then I fine-tuned the twin transformer networks on the data I have created. In terms of the results, we consider the Spearman correlation as representative of the ability to accurately determine whether two verses are similar. The table here shows the Spearman correlation for cosine similarity using the different combinations of relevance degree for similar pairs for our model. Our model achieved a score of 84.96% with Arapert using the pairs with the relevance degree 1 and 2 from Qasim corpus as the similar pairs. We evaluated our model for predicting similarity using the Quranic semantic similarity dataset. The evaluation metrics we used for this task are accuracy and F1 score. We computed the verses embeddings for each pair in the test set using the Siamese Arapert networks architecture to be used to calculate the cosine distance and determine how semantically similar they are. Using a threshold of 0.6 for the cosine similarity, we consider the pairs with similarity equal or above the threshold to be related, otherwise non-related. We then compared the actual result from the annotation in the dataset with the predicted ones using our model. Our model scored 95% accuracy and F1 score of 95%, as shown here. From all classes, positive and negative, we computed the accuracy as how many of them we have predicted correctly. Here we have 6,114 out of 6,436 predicted correctly, and 5,910 out of 6,236 predicted correctly. These are examples of instances where the model predicted correctly in the first example, however, failed to predict the similarity in the second example. It could be the threshold we've used is high. You can see here the similarity is 56%, which is closer a little bit to the threshold. I had a closer look at those instances that were predicted wrong, the false negative and the false positive. This example is false positive. I found something interesting here. The similarity between the two verses seems ambiguous as the meanings are not close. However, my model has detected a similarity of 60%, which reveals a deep relation that commentary books have not pointed out. By referring to Al-Tabari commentary, the discussion has emerged from the previous. I found that the discussion has emerged from the previous verse to the one on the left and extends to that verse. Therefore, the two verses point out that God Almighty tests believers by al-jihad against the enemies to distinguish those who have insight into His religion from those who have doubt and confusion. To conclude, my model could indeed reveal an embedded relation between the two verses. We further report performance of our model on the same dataset compared against systems of earlier work based on accuracy and F1 score, as shown here. In conclusion, this study presented a verse embedding using Siamese Arabert networks for fast and efficient semantic similarity detection in the Quran. Our model succeeded to detect the semantic similarity between the verses of the Quran at different levels and diversity. The model succeeded as well to reveal the extent to which the passages of the Quran are related to each other with consistent meanings and regular structures. We can say our model succeeded to uncover overlooked places in the Quran that the manual investigation couldn't have uncovered. Thank you for your attention. I'm grateful for such a great opportunity. Thanks as well go to my two supervisors, Dr. Eric Atwell and Dr. Ammar Al-Salka.
So those are all the presentations for this session, but do we have any questions for anyone who presented in the last hour? So interesting questions. I mean, I have one question, if no one else does. It was actually for your talk, Banji. I was just wondering how, it was interesting that you looked at how it was like the verb noun combination was the one that performed quite well in your model. I was wondering to look at anything else that affected how well your model was able to match present an image of the action. But there are other things that you looked at to look at to see what affected the performance.
Previously, we have the action slate, the verb noun. Then
Yeah, so you had as your, I'm trying to remember exactly, as your input you had, it was a verb noun combination was what you decided to use. But were there any other combinations or types of phrases or inputs that you saw and decided not to use because of
really a wide combination with action and prediction, that description, and have we tried other kinds of description?
Yeah.
That's a good one. Why we combine with the effect prediction is that we want to predict the interval state. So the direct That's good.
Thank you. And David?
Can I ask the final talk? But the errors that the system made, were there obvious reasons why the system was making those errors to do with, say, word ambiguity or something like
The
that?
final talk was that
Yeah.
by
The video, right?
the video. Was it, wait, I can't- wait, sorry, I'm trying to get the person's name back up.
I can tell you.
This one. Was
Me
it
and my God.
so that was just a recording. They weren't
Oh, it was
listening,
recorded.
sorry.
Am I the only person who didn't realise? What's the answer?
But if you look at the examples of sentences, they're very complicated. So the answer is nobody knows. They're too complicated for ordinary people to understand.
It did seem really complicated.
Yeah.
The ones that were similar were quite
So
difficult.
the decision on whether or not they were related was done by Quranic scholars, not by ordinary people, let alone PhD students.
Yeah.
And
And yet, the scores were incredibly high.
Yeah.
This is really amazing.
so it is agreeing with the Quranic scholar rather than agreeing with me or you.
Yeah. Yeah.
If not, I will free you. Thank you for joining the session. As you know, there's refreshments and everything else still upstairs, so feel free to pop there before popping off to your or staying for the next session.
Thank you, and to everyone. There is fresh tea and coffee and some food left upstairs. If you're staying in
Now then, that's it. So when you're speaking, you can stand up where I am now. Yeah.
Okay, yeah.
So what we need to do is we need to share video. Where's that option? Share screen. Yeah.
And this one.
That one. Good. Glad you can see. Okay. And you've got 10 minutes. I'll give you a shout at 9 minutes.
Okay. Okay, so again, my name is Sophia. Some of you might know me, and today I would like to speak about one part of my research, which is related to development of bi-sequence similarity search algorithms. And there is math there, but today I will be talking about computational science. It is computer science conference. So I will talk about a few tips which have been done here. A quick introduction into the problem itself. Processing genomic data is a very common topic in many biosciences applications or medical applications. When research team has to process genomic data, and here we talk about the whole reference. If we talk about the whole reference genome, it is roughly 3.2 million of symbols, so big data. And one of the common topics is to do matching of many millions small subsequences to find their location within the reference genome. So this is a big data problem, and it is computationally intensive and challenging, especially for some of the problems where you have to match many million reads either against each other or against a reference genome. And if you go a little bit back in the past, then here we are talking about global local alignment problem, and it has been solved mathematically back in 70s, 80s. There were suggested two major algorithms. However, it was still very challenging to compute at those times because computational time complexity is big O and M. And we talk about N and M length of sequences we are comparing here. So it takes a lot of time. It was very challenging and not very much manageable at those times. And in the 80s, research groups started suggesting various approaches how to speed up calculations. Heuristic approach, which is more about matching not all maybe sequences, but a reasonably high proportion of sequences. And it also helps to reduce the computational time. And here we talk about innovation such as filtration and indexing methods. When I talk about filtration, it means that we use so-called seeds, little small contiguous bits of sequences, which we try to allocate first against the long reference genome and find so-called candidate places. Once we have a list of candidate places, we start doing proper referencing. And by doing that, we reduce the computational time tremendously. However, there is sensitivity becomes not 100%, but lower than that. So this is a trade-off between sensitivity and the computational time. And there were various other improvements made within the time. I'm not going to talk about them. There is a very good survey paper. You could look it up. I want to focus here on the seeding problem and talk how it could be improved, how it could improve the computations. In our approach, we decided to study a few questions. Our preprint, research preprint, I can refer you later to it. What would be the optimal structure of seeds of these contiguous subsequences, which we use to find all candidate places to optimize the searching part of the algorithm? More importantly, and what we should start with, how to store the data in an optimal way, so to optimize all following processing, post-processing of data, and how to perform the comparison efficiently. And what we thought about, we decided to approach from the side of not using the minimum possible amount of storage to allocate the data, but the most efficient. So a compromise between a storage space and efficiency. And why we're doing that? Because in the past, storage space was a problem. Now it is not anymore. Even home workstation, which we have at home, could easily have in average 128 GB, could be easily upgraded to a higher amount of memory. So we don't need to bother about space as much as we used to in the past. But what we bother about is how to process data afterwards. Right, and we suggested to use the following approach. Treat all the reference genome, all the information by blocks, by 32 symbols blocks. Each block, I think it is easier to show on the next slide, because we have only 4 symbols here. The reference genome contains only 4 types of symbols. We can code it as 0, 1 binary vector. 1 corresponds to the location where the letter presents, 0 when it is not present. Why we do binary? Because they're extremely easy, fast to process, to compare. So here we just apply logical operations and other operations as well, and we can do very quick comparison between sequences. Another slide. So we use a low-level intrinsic function. Intel provide with low-level intrinsics, which are extremely fast and can give a number of how many letters exactly matched between 2 of these strings. Right, and actually we work not with the contiguous seeds, we work with spaced seeds. It has been proved before, shown before, that spaced seeds, so seeds where we don't require to match every single symbol, but we require that some positions has to have exact match, and about some positions we don't care. So those are binary seeds, proved to be more efficient. We applied our algorithm, we did the tests and simulations, and we found not only binary space seeds are more efficient, but they have to have a specific structure, which is a periodic structure, and we provide with the optional seeds as well. Another trick which we also use, which improves the efficiency, is not to work with the seeds, space seeds how they are, but shrink them into 32-bit word. And how do we do with that in an efficient way? Well, here we divide it into 2 rows, 32 and 32, and the approach is to move the second row in such a way so all ones go in zeros in the first row. So as a result, we have one contiguous row with 1, 1, 1, 1 at every location. And this could be done by many ways, but we provide an our work algorithm which can do it in an optimal way. So how to find an optimal number of shifts or optimal shifts to minimize this procedure and to get this contiguous bit. So those are only 2 of the tips which we used. There are more details in the preprint. Anyone who's interested could ask me, and I will provide you with a PDF file to look into. The main idea which I want to say here is we work in genetic, we work with big data, and they're increasing, the volume is increasing more and more with time. So it is extremely important not only to look at the mathematical part of it, very important part, but optimize it computationally, optimize to make sure that it works, uses the HPC systems efficiently and calculates things fast and efficient. Thank you.
1 minute left. Okay. Right, thank you very much. So we'll be taking questions at the end.
Right.
The next person will be Ben Hanson. Thank you very much indeed. So I'll take that minute. You're going to take that minute. I'll take that extra minute. So that's you. Yeah. Yes. is where I should put my reading glasses on. There we go. That's still sharing. That's not sharing. I didn't share that, did I?
No, don't steal it. Well, don't be stealing it. Look, I've got philosophers on it. Get back here.
The other one, eating.
Meeting.
Oh, ruining it.
Sorry, mate.
Sorry.
Where's that? That's maybe to close the other one. Share that. That one. That one. I'll give you a shout at night.
All right. Thank you. All right, we've got it. Okay. Hello, everybody. I am Benjamin S. Hansen. I have to put the S in because there's another me in UCL who comes up first on Google. So Benjamin S. Hansen. And I'm going to be talking to you today about thinking about new paradigms for biophysical simulation. So I'm a biophysicist, computational biophysicist. And one of the big things that happens in computational biophysics is people want to do all atom simulations of the cell quite a lot, which is bad for the planet. So it's unpicking that idea, going low resolution when you can. So I'm going to go full academic on you. I'm going to start quoting philosophers at you immediately. So this Friedrich Nietzsche was an all right guy. He says we're all driven by a will to power. He says so-called good behavior doesn't come from deliberation, come from the powerful enforcing arbitrary standards. That's nice. This guy, depressing guy, Albert Camus, he says there's no meaning to anything at all. We just feel like there is. And we have to resolve this dissonance to remain sane. That's what he says. So these two together, Nietzsche basically says neither science or knowledge are good. Camus says to give meaning to life, you've got to decide what's good for yourself. So if we bring these guys together, they basically say we cannot say it is science and therefore it is ethically justified. We can't be doing that anymore. We have to do good science if it's going to be ethically justified. So I'm going to take you through a few models that I've been using in my career to try and do something about this. Yes, if we focus more on brains up front, there's a little image I did. Let's skip that. Fluctuating finite element analysis, right? Finite element analysis, for the people in the audience who've come across it, going to make it wobble like biology does. So here's a picture of a monomer of the molecular motor dynein. That's all the atoms drawn in VMD, so it's super high resolution. We say no, screw that. Let's just draw a computational surface over the top of it, coarsen it down even further so that it's just got that general shape. Here's the equation that simulates that in continuum mechanical land. We'll not worry about the maths of it. We can turn it into a matrix equation that computers can deal with, get rid of the one that's too hard to deal with. And then here's the simulation equation that we would use, which looks like something that MD would use, but it's a lot lower resolution. We had thermal noise in on one side, give it some statistics, and then all of a sudden, oh, that's supposed to wobble. Oh, okay, that was a simulation. So it wobbles around. So I can take two atomistic structures. I can take two high resolution molecular dynamic structures, one with ATP and one with nothing in it, or ADP, a different molecule in the binding site. I can take their minimized structures, pass them through this algorithm, calculate their material properties. So the one that's got ATP on it has very different material properties to the one that doesn't. And once we've parameterized these things at high resolution, we can then dump them into much bigger systems where a lower resolution would be more appropriate. So that's what I'm talking about here. I'm talking about multi-scale throughput. So you start off at high resolution until you don't need it anymore, and then keep moving from there. So we'll see a bit more of that towards the end. There's this other one I've been using called BioNet. I called it BioNet. So this is where proteins are spheres. We all know this as biologists and physicists, right? Proteins are spheres. And that sounds like a joke, yet if you do that, if you make a sphere and you just add these specific sites to the surface, instead of worrying about where all the atoms are and what's an active site and what's not, what's charged and what's not, you just create these active sites, things that can stick together, and all of a sudden you can get polymer physics coming out with nothing other than these things being stuck together at the surface instead of center to center, right? So just by adding a few specific extra degrees of freedom, you can get different polymeric properties. So that's super good. You can also make these things stick together over time, and you get massive complexity emerging from just these simple structures, right? with a bit of physics added on top. So at no point do I care about where any of the atoms in there are. That's not important at this scale. And obviously it's not even this scale, it's really this scale because we've got the computer, right? So it's much bigger. Right, but you can't really see what's going on there. Science is small. So you can do different things. So if I create polymers to start with and make them stick together, if that's super rigid with not many sites on it, it doesn't make much. But if it's super flexible with loads of sites on it, you get a really dense, porous structure that things can diffuse through. So my student Guan Yi at the back is going to help me look at what's going on. Hi Guan Yi. Hold on. So she's helping me with this sort of stuff. Different networks, how do small molecules diffuse through this? How do proteins work as active sites in this unit? So that's the sort of other thing we can do, just pretend that proteins are spheres. Here's some results from that. It doesn't really matter because I haven't got that much time. The last thing we're going to do is look at this thing called a mechanokinetic model. So instead of us human beings being the ones to say, okay, this is what matters, this is what matters, this is what matters. Imagine if we could get a computer to tell us what matters, kind of like where you do machine learning but unguided. More of the physics application of that. So if I've got 5 states and I can move between states, right? So that's a standard view of a chemical reaction network or any sort of network. I've got a state that I can be in and I can move to this other discrete state and I can move to this other discrete state and there's rates at which that happen. So populations move between these, they change their size as things move between them. Inside each one of those states, if I'm a molecule, I'm not just stuck here still, I'm fluctuating around, I've got temperature, I've got all these other energy things going on. What we can actually do is do some clever maths to integrate out all of the mechanics in each of those things and then add them back in as part of the simulation. So that might sound crazy, but what I'm basically saying is for the same structure at this scale, I can change what's going on under the hood to change the mechanics of what's going on and get the same sort of probability distributions. So this and this has the same density in each of the states. It's just spread out in different ways. And we can analyze simulations in order to work out what these things are and go backwards. It's called the Markov state model, but it's another way of doing it. So it's like a continuous way of moving backwards and forwards between continuous dynamics of springs and things stuck together and discrete things that are happening at the next scale up. And you can also use that to do protein unfolding. Recently submitted this paper, right, and invited the guy who was going to be one of the reviewers to a conference. And he said it's not even science. Can you believe that? It is science, and it's on the archive. So let's say that this is all real and it's all believable, and we can do it. So you can do this. What you do if you do protein unfolding is you find that if you take out the effective temperature from proteins that unfold, you lower the effective unfolding force, proteins unfold at some force, by about 20 piconewtons or about 10 to 20%. So if you take out the dynamics of how proteins move, just completely remove them, you lower the effective unfolding force. So we can see using this sort of model which parts of a dynamic process are important, get rid of them, put them back in as we need in sort of a continuous manner. These are the graphs that show that, but it doesn't really matter too much. So going back onto the molecular motors and stuff, we can actually take this idea of moving between different dynamic states and put it into a continuum model. So here we've got something that's wobbling around as a parallelohedron, and now it's a cube, right? So its equilibrium state is a cube, but all of a sudden it changes into a parallel. This is like a protein unfolding. It changes state, wobbling around the new state. Those dynamics and kinetics of models. We've also got a molecular motor here, so you can see this bit. Does this have a thing? Yeah, you can see it. This thing is called the linker, and this whole middle section chemically rearranges and it causes it to generate force. And we can use the whole mechanics of this to work out what the force is and combine it with the state change to get realistic simulations without ever considering the atomistic processes that lead to it. So that's the idea. I think that was about 10 minutes. Dot, 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 dot. Let's get some more theoreticians involved in mesoscale biophysics. There's not enough of us. We need more. So thanks and questions. The fluctuating finite element analysis is Sarah Harris and some mathematicians and their entire group, Bionette Law group and her entire group, mechanokinetic model, everyone. Questions at the end.
Questions at the end?
Yes.
There you go. Okay, that's you. Good. You're going to be on camera. Well, that's you, isn't it? You do need to share that. Thank you very much. Screen number 4. 10 minutes and I'll give you a shout.
Hello everyone, I'm Hamza Ramdi. I'm a PhD student supervised by Professor David Hawk and Professor Andy Baldwin. So today I'll give a talk at the first part about the video synthesis of token head. And then the second part I will talk about the challenges and the packages that I use on R3 and R4. So what is actually token head video generation? Suppose you have a video of Professor David Hawk.
It's a major research-intensive institution. We have a very substantial equipment base, and this requires a large investment, both to capital to replace the equipment, but also for running costs to keep it running.
We want actually to take the audio of David and generate a token head of Theresa May, lip-synced with David's voice. So let's see the result.
It's a major research-intensive institution. We have a very substantial equipment base, and this requires a large investment, both to capital to replace the equipment, but also.
And what about Barack Obama?
It's a major research-intensive institution. We have a very substantial equipment base, and this requires a large investment, both to capital to replace the equipment, but also.
Basically, you can have any target head, basically.
It's a major research-intensive institution. We have a very substantial equipment base, and this requires a large investment, both to capital to replace the equipment, but also.
What about the other way around? You have a video of Barack Obama, and this is the.
Anaya, thank you for that beautiful introduction. I could not be prouder of everything you've done in your time with the Obama.
We want to use Obama's voice to, drive the David's head.
Anaya, thank you for that beautiful introduction. I could not be prouder of everything you've done in your time with the Obama Foundation. And
you may already wonder what are the applications of this, and someone already asked in the morning actually. So one application in the entertainment, video dubbing, basically you have an original video in a language and you want to replace it with different or other languages. So this is an example of that. And another example, actually, virtual assistant, basically Siri, but it's actually virtual. And this is an example generated for this conference.
Hello, this is demonstration for Research Computing Conference at Leeds.
Basically, there are other applications, useful applications, for example, educational videos or synthetic data for training. And there are many other applications. So actually, the goal of my research is actually to build a generative model, deep learning model that takes a single identity and speech audio and generate the video of that identity lip synced with the audio. So for this example, we have this identity and the
She had
audio.
your dark suit and greasy.
And we want actually the model to be able to generate, a video lip synced of that identity, that given identity, lip synced with the speech.
She had your dark suit and greasy wash water all year.
One more result of my work, basically just taken from a single identity. Here.
Hello, welcome to Research Computing Conference 2022 at Leeds. This video was generated using artificial intelligence.
So the audio I'm using here is actually used, I just used an off-the-shelf text-to-speech model to generate just given the text to generate just the speech audio, but then I use my model to generate the token head, basically. Next, I will actually talk about the challenges that I faced during my research. So one challenge is actually the data size, and in general, audiovisual data sets are very large, and they take a high volume of storage. So a video is a sequence of images called frames, and videos usually sample at 30 frames per second. So basically, for a second, you have 30 images. So an image is actually two-dimensional grid of pixels. Each pixel actually take about 1 byte, and so an image of size 1920 by 1080 would take about 1 megabyte. And so a 4-second long video would take about 120 megabyte. And usually, one of the methods that I have is actually 1 million video. So it takes at least actually 120 gigabyte. This is just only the video, not the audio included with it. The other challenge is actually data pre-processing. So for every single frame, I need to actually to find the face of the talking head. I need to crop the face, and so I need to pre-process basically the videos. And for a single frame, it would take about 10 seconds to pre-process just a single frame. But so if I have that's 1 million videos, that's actually the number of total frames, about 120. Assuming that each video would take 4 seconds long, is actually the number of total of frames is actually 120 million frames. And to process that actually on a single machine, let's say on my PC at work, it would take about 138 days. But luckily we have Arc 3 and Arc 4, so I could do this in 1 to 2 days. So very quick, basically. The next I will talk about the packages. So because I work a lot with Python, and I use Anaconda to manage Python packages on Arc 4. And it's really simple. If I want to install any package, I could just basically run after I create the environment, I could run the command conda install the package. And for example, here's NumPy, and actually Conda will sort out the versions of the packages that need to be installed within NumPy. The other actually package is actually PyTorch, and I use it for training deep learning model. What I really like actually about PyTorch is that if I want to run the model, train the model on multi-GPUs, I can simply add in this line, basically passing the defined model to the torch and then data parallel, which is a module in PyTorch, and this will take care of the training on multi-GPU, basically. Without telling, basically this module here is actually will detect how many GPUs available and will actually train them on the available GPUs. The other actually package that I use is called FFmpeg, which is actually package actually to handle videos, working with videos and audios, basically decoding video in frames, extracting an audio from a video, converting video format. For example, as here, I want to convert from MP4 to AVI. So basically, I work a lot with FFmpeg, and they are actually very fast. There's actually, I think, a Python wrapper for this one, so you can a Python version, so you can use it within Python if you want. The last package that I use actually TensorBoard, and I use this actually for monitoring training. Some of you might be familiar with this. For example, to plot losses, to monitor the GPU's usage of it, to visualize generated videos, basically, and I can just visualize all of that using the browser, basically. They're very simple. There's actually new things called weight and biases, which you can do this online. So basically, you can go to a website and you can see your trained model instead of like needing to connect to the server. I think that's all from me. That's it. Thank you.
So our last speaker of the afternoon, and then we'll take some questions. So we'll just get you set up. There we go. That's good. Yeah. Good. Excellent. Yeah. Yeah. Good. Excellent. So we'll just go back. Share that. Good. Super duper, and I'll let you. Okay. Right. Okay, so I'll give you a shout 9 minutes, and then we've got 10. Great, thank you.
Have a check. Yeah, cool. Okay. Thanks for having me. And today I will give a very short talk about our work, how to train the billing skill model in an affordable and faster way. So in the last 10 years, we can see the machine learning and deep learning are at the springtime again, right? So, so nearly all the researchers in the academia and all the engineers in the industry are talking about AI, right? But absolutely, this time, the machine learning and deep learning are truly contribute a lot to our life, to our real world. AI for medical, AI for physical, AI for environment, anything, right? So let's dive into the development of the machine learning this time. So let's see the first time, as for the traditional machine learning, it homogenizes the learning algorithm. So the next is the deep learning. Deep learning, it homogenizes the model architecture, like a convolutional neural network, graphic neural network. But this time, we found the foundational model. Foundational model, it homogenizes the model itself. So what's the meaning of the homogenizing the model itself? So in the foundational model area, we use all kinds of the data. All kinds of data includes text, image, video, all kinds of the data to train one model, one large model. And then we can adapt the large model to different downstream tasks. That means we only need to train one large model, like GPT-3 or BERT, to deal with all kinds of the tasks, right? So this is the foundational model. In this area, after the training and fine-tuning, we can also reshape the model size from large to small for the mobile or the edge devices, right? Using other technologies like knowledge distillation, network pruning. But here today, we're only talking about training the very, very large scale model. So we can see the first solution is money, right? Money can buy anything. So at the first stage, we can buy hundreds of and thousands of GPUs to train a large model like GPT-3, GPT-3 here, right? So, but we can see the curve. The red curve means the model size. The blue curve means the GPU memory. Then we can see in the last 5 years, the model size increases 20,000 times. But the GPU memory in the last 5 years is only increased 6 times. So nor, at present, we have no more money to buy more and more GPU resources to train the large model. So how to train the large model at this moment? So our solution is from the heterogeneous resources. We have no more GPU, but we already have CPU resources. In the CPU side, normally the computing server will have the 200 gigabytes in the CPU side, and in the cloud server, a high performance server in the cloud side, and the DRAM can reach to 1 terabits or 2 terabits. But in the GPU side, the latest version GPU A100 is only has 80 gigabytes memory. So is there any possible way to fully all of them to train a large model? Yeah. So let's see the training process first. Yeah, it normally have 3 steps. The first step is forward propagation, backward propagation, and optimize the update. Right. So here I give an example. We use 8 GPUs to train a larger model based on the model parallelism. Model parallelism means we split a larger model into smaller pieces, and each piece is located at 1 GPU. So during forward propagation and backward propagation, each pieces will communicate with each other to finish their calculation. So this is the default way. So how about this way? We only use 1 GPU, but we offload the inactive parameters from GPU side to the CPU. Yeah. So the dynamic offloading can save a lot of GPU memory. Yeah, as layers. The most challenging thing here is the performance. So how to keep the same performance after introducing the offloading actions. Yeah, and if the performance is very fast, I mean, if the training time increase a lot, maybe the work is also meaningless, right? So how to keep the same performance? So here I just give some core design here, and to talk about our work. We design a working window in the GPU side. It stores the active parameters. It means here. It means here we while at the GPU computation, we offload the next candidate layers from CPU to the GPU, and simultaneously we offload the computed layers from GPU to a CPU. So the transmission between CPU and GPU and computation in the GPU side are overlapped. So this is the forward propagation. So how about the backward propagation? Backward propagation same as the forward propagation. So we load and offload the parameters between GPU and CPU based on if the parameters are active or inactive. Right? But here we also introduce an improvement. It's like the parameter update. Here during the backward propagation, if one layer is finished its backward propagation, so it can trigger its optimizer update immediately. So that means the backward propagation and the optimizer update can overlap again. So it will also, increase the offloading performance. So this is one of our evaluation results. The first bar is the baseline without the offloading actions, and the next three bar is the existing works with the offloading actions. And this is our work, and we can train about 23 times larger model than the baseline, and about 1.9 times and 6.5 times larger model than existing work. And this is the throughput. Throughput means performance. And in our work, we also keep the performance at the 1.2 times and 3.9 times improvement on the training throughput. Yeah. So this is our work. It's a briefly introduction. And if you want to more details about like multi-stream execution or scheduling tensor or etc., and feel free to email us, and welcome any questions. Thank you a lot.
Thank you very much. Okay, so opportunity now. If any of you've got any questions for any of our speakers, and we'll let people take those.
Question to the last presentation.
Yeah.
What sort of frameworks and libraries are you using at the moment?
Framework is PyTorch based on PyTorch.
Do you mind just coming up to the front, because remember this is being live streamed, so we'll repeat the question. And if you want to answer the question. So the question was.
What frameworks and libraries are you using?
Yeah, the framework we are using is the Magnetron LM. The Magnetron LM is released by NVIDIA. Yeah, it's based on the PyTorch. Yeah. So yeah, it deals with the model parallel problem. Yeah. That's it. So any question?
Okay. Any more questions for any of our speakers? So I've got a question for Ben. So you had lots of dots and dots and dots at the end. So where are you immediately going to take this work? What's next in your pipeline of developments?
Sarah, what's next in our pipeline of development? And also all the low resolution stuff. What's our plan?
Better physics.
Better physics. We need more minds. We need to put grants in for more. We need to.
That was your last point.
Yeah, we need to advertise, and we're writing a paper to do this. So keep your eyes open. But we need to get more people interested in things that aren't high energy astrophysics and quantum mechanics. We have to show that biophysics is itself interesting and a frontier of physics, which it is.
So bottleneck has been more a people bottleneck.
Something like I would say, yeah, actually, is, like I jokingly think that people are asking for all atom simulations of the cell, but whenever I go to a biology conference, people are like, oh, like where are all the atoms? And I'm like, well, they don't need to be there. That's the point. And as a physicist, you're like, oh yeah, right. Obviously, it's a sphere. It's not a sphere. It's just a model, right?
Yeah.
But it's getting that connection together and getting people excited about the idea of having a continuous model from top to bottom that loses detail as it needs to keep everything environmentally friendly.
There we go. And that I guess is a key issue. In fact, for everybody's research, for our last speaker there as well, that one of the huge benefits this has is that all of this computation intensive research is a climate killer, really, isn't it?
Yeah, there's a panel on sustainable computing tomorrow.
Which we all need to hear about, don't we?
Yes. Good plug.
Indeed. Okay. So any final questions? Any other questions from anybody? If not, oh, go on.
I've got a question for Mohammed.
Okay, excellent. Thank you.
During the data processing part, is it enough to just close the image from the lips part, not the whole head? Is it enough for the lips part?
Oh, okay. This is a good question. But there are actually some work have been done that only generate just the lip, other than but we won't actually generate the whole frame. So in my case, I'm generating the whole frame, basically the eyes and everything, and the hair. So that's why I need the whole face basically in this. But there are other works. For example, David has showed in the morning that the friends show. So basically, they only generate just the lip. That example.
Okay, thank you. So have you tried some data about dancing and singing together, and like a person is dancing and they sing together?
You mean generating dancing?
Dancing and singing together.
Dancing and singing. I think there are people who are doing dancing generation, and there are also people who are doing actually just the upper, just the head singing. There are actually data set for that, but I haven't. I wanted to try this actually. Just getting someone to sing. Actually, too.
So lady in the back row, and then Sarah.
How complicated it is to move from using the person's own voice to the other person. So, for example, you presented a video where David Hogg is speaking, and there was a woman. And then, so for example, I want to use the woman's voice to present the same text or the same audio. So, how complicated it is to move your model from speaking with the person's voice to the other person's own voice?
So your question is about what if I can make, for example, Theresa May to say the same speech that David said. So basically, in my method, I'm only generating just the video. So I'm assuming that I have I'm given the audio and the identity. But usually in research or other, like for example, Siri or Google Assistant, they have like models called voice cloning. Basically, you have a recording of an audio of 5 minutes, and then you train a model that learned how, for example, David speak or Theresa May speak, and then it's basically these models are kind of like text-to-speech model, but it only require, I think, just 5 minutes of the target.
So does it produce like a video or audio that
No, just audio.
That uses the person's own voice? So I would hear David Hogg and Barack Obama speaking about the same thing, but they're using their own voice, not the other's voice.
Yeah, so they are actually generated separate. So I need the audio, so I could use voice cloning deep learning model to generate the audio, and also I can use, like for example, my model to generate just the head. So the first thing, I need the audio, generate the audio, and then generate the token, the video basically. Okay.
Sarah, you had a question?
Well, it's a bit of a little one really, but you can do this with people, but I'd like my molecules to be anthropomorphic. So I'd like my molecules to talk and dance. Would I be able to somehow?
You mean like yourself? I think the model.
No. So I have movies of molecules undergoing thermal fluctuation.
situation. So I have these molecules that move around and change shape all the time. But wouldn't it be fun if I could get them to look more human-like in some way, the science communication? Would I somehow be able to, I don't know, give them,
Give them a character.
Like,
Yeah.
give them a character?
There are actually, I can put you to papers that have something to say.
Really? Oh, that's
Like driven by music. And driven by,
yes, that would be amazing.
I think I've seen papers. But many people work on it.
There we go. So that's an interesting one as well. Then. Characterizing, whatever that word is.
Oh yeah.
Yeah. I've got a question for Sophia, if you don't mind. Sorry. So right at the very start, I think you've mentioned that some of those algorithms used broadly by informatics sort of date back to the 70s and 80s, when data sets were much smaller, but also computers were much smaller as well. And what you've got there is a really interesting sort of optimization technique that allows you to grow. That allows you to grow as the data was growing faster than the hardware. So are there any other algorithms in sort of classic bioinformatics that you've identified that are a sort of candidate for these types of techniques?
Yeah, that's later actually. So I mentioned those two in the 70s. They were doing with dynamic programming type of problems, and they were guaranteed to find optimal global development alignment. And in 80s, they started using heuristic type of approaches where they don't guarantee they line every single, but like 90+%. So for the cost of sensitivity, but with a speed up and reducing computational complexity. After that, there was model wheel transform. You probably have heard about it. That improved and various seeds starting with short contiguous. Then there were various spaced seeds. Then they started using k-nears for alignment-free type of algorithm. This is one of the latest things, which I think the idea is really adapted, and they go from one algorithm to another. Similarly, you can see k-nears is quite similar idea. Is rooted, I think, in seeds and spaced seeds and contiguous seeds and then spaced seeds. Yeah, and still they don't guarantee to find all the align fully all the sequences. So it is still the problem. I think, especially with the metagenomic data.
Yeah. Cool. Thank you very much.
Thank you.
Okay, so that brings us to a close for this session. We've obviously got another session about to start in 3 or 4 minutes. So what's on in here, John? So Conga Code Clinic in here, and we've got a panel, I think, in the other room.
Open research to start.
All right, mine's right there. You're on the right there.
Oh, yes.
3 o'clock, sorry. 3 o'clock is the panel on open science. That's in the other room. That's it. Thanks. Yeah, there we go. So you're in here for the rest of the
Yeah.
Good. The other room is back by the back by the it's I'm going there. Yeah. It's where we were this morning.
Oh yeah. I'm not starting till 5:30. So.
Right. 10 past. That's about to start. Right. Hopefully you are here for Conda Code Clinic. I'm going to quickly run through a quick introduction to Conda. Hopefully do a quick live demo, and then just open for question answers or any help or anything you need. So to start with, who am I? I'm Nick Rhodes, research software engineer. Probably fair to say I've got a bit more of a system focus rather than end coding or operating systems. I've got 2.5 years working with researchers in the research computing team. Background-wise, I'm a computer science graduate, almost 25 years of experience spread across many areas of computing. Done everything from networking to leading support teams. Still lots to learn in the realms of research, and that's part of the reason I like the job. There's new avenues of research. I pick up computing all the time, and I really like helping researchers to use computers better. Everything from writing code better to using our HPCs as well as possible, and that ties on to Conda. Conda is a tool that can help you manage and run your software code projects better. Historically, it was used for data science. We were focused on Python and R. As it's got more popular, it's moved to sort of more general scientific computing. So another common use nowadays is for ML deep learning frameworks, installing and managing those. And what it does is it provides a package manager for managing your software libraries, versions, dependencies. It can manage environments, which are isolated areas to install packages into, and you can use different environments for installing different versions of software libraries. So for example, if you need different version of Python, you can create a separate environment to run a different version of Python. There's a GUI management tool that allows you to. Okay. Is it really late? Right. I shall go slowly then until people arrive. Yeah. So yeah, Conda provides a GUI for managing packages and environments, and a good command line. The full installer includes both. Mini Conda, which is a smaller installation, just provides the command line. So why use Conda? So it's something called configuration management, which is where you organize and manage the configuration of your software dependencies environments, and you store that in a codified programmatic manner. So rather than going, oh, I'm writing some code, I need to download Numpy, I'll go get it off a website, and then a bit later go, oh, I'm doing something with pandas, I'll go download that pandas website, you stick it in a directory, you forget about what versions you're using, and you've got no way of keeping track of per project what's stored where. So Conda is really good for that, and it helps with reproducibility. So someone else comes along and wants to look at your code, try and reproduce the data you provided. You've basically got the recipes there for providing the libraries, the versions, the environments to actually get that up and running. And reproducibility, it helps with quality research. Turingware's website's got a really good background on reproducibility and why it's important. And open research as well. So you don't want to have your code locked behind sort of closed doors. Conda's an open source tool which everyone else can use without license, and it promotes, because of its open sort of distribution model of the packages, it promotes open source libraries and software to use there. And as I mentioned, it provides, you can use it as sort of the canonical source of your sort of configuration for your project as well. So in terms of in a sort of central place. The security as well. So this is a big bonus in the University of Leeds, where a lot of people with PCs, they don't have admin rights to install stuff. Conda doesn't need admin rights. each user can download a copy for themselves and install it into sort of their own sort of user space, and it's kept separate from any other user. And it's quite universal. I won't say it's perfect, but it doesn't rely on dependencies from the system itself. So if system provides Python 3.2 only, Conda doesn't have to use that. Conda can will by default use its own version, which is probably 3.8, 3.9 now. If you need 3.6 or 3.7, you can install that. Doesn't break your system, which is what can happen if you don't use a tool like Conda, because you end up having to mess with conflicts or replace system libraries. And it runs on a lot of things. So it runs on our HPC system, it runs on other people's HPC systems, it runs on desktops, Linux, Macs, Windows, and different hardware architecture as well. So sort of standard Intel desktop chips, IBM Power 9, and a few ARM architectures as well. So it's I mean, it's not perfectly universal, but it's far better than anything else you can get. So what Conda is not, it is not version control. So it can't manage your source code itself. You'll need to use something like Git, GitHub, GitLab to store and manage that. It's not a workflow management tool. It only manages your software configuration. So if you need to manage entire workflows, you need to use a tool like SnakeMake or Nextflow. And it's not a container. It isn't a full working environment. It doesn't include the operating system level components to have something that will work by itself. If you need that level of sort of standalone independence, possibly for compatibility, where system level libraries like drivers that are required to work with are they're needed to make a working piece of software for your research, then something like Docker or Singularity is a good way to bundle out together. Sometimes it can be a better way using containers, can be a better way of using things that Conda's not very well supported. So if you're doing things like so the libraries aren't there, packages aren't available in Conda, then you might find something like a container a good way to sort of piece that all together. It's not a repository platform. It doesn't publish anything for you. It doesn't store anything online for you to for your project to be sort of distributed. So again, you need to use stuff like Binder as a node to do that. And it's not automatic. It isn't magic. It only helps you to manage and maintain your code. It won't do that for you. If you abuse Conda, it will bite you in the bum later. If you just willy-nilly install packages, override dependencies, it will break. So you have to use it sensibly. And so Conda alternatives. So why would you not? Why Conda and not something else to start with? Some alternatives need admin rights. Some alternatives don't work on HPC systems. Some are far less user-friendly. Not every researcher is a computer science programming expert. Some of them just need the minimal programming experience to do the data analysis they're required to do their research. So there are some alternatives. Python, you've got pip, VM, Poetry for managing packages and environments. In R, you've got CRAN and RM. In other languages, there's various tools, Cargo, Maven, NPM, for various languages like Java, Ruby, Rust, Node.js, etc. As I've already mentioned, there's containers. So in terms of, they can define your environment from a definition file. Virtual machines, you can go in a step up, sort of outside up from containers. You can use Vagrant as a tool to manage and build those for configuration of those virtual machines. But the main reason we use Conda is because it's the most universally usable tool across university, and it's quite user friendly and works on a lot of things. So that's, as a research computing team, that's what we recommend and use ourselves. So getting Conda, it's quite worded this, so I'll just rattle through it quickly. In a nutshell, you can just get it from the Conda website, download it yourself, pick the full version, or go get Mini Conda, which is, and just say we actually recommend Mini Conda ourselves because the full installer installs a lot of packages that most people don't use even half of. It provides a GUI which, though easy, it's easy to get lost in managing your packages and not seeing explicit lists. And it doesn't work on HPC, on ARC3, ARC4, so you will still need to use command line to get something working on those systems. So yeah, and a lot of people on the internet, if you look at a lot of documentation, they often recommend Miniconda because it's faster to download and install and get started with. So in terms of Anaconda, so it works on the concept of packages. A package is like a unit that you download. It's actually a compressed archive of some format I'm not sure of, and it can contain any combination of software, libraries, and the metadata. And in terms of metadata, that would be version, the specific build of that version. So sometimes you get builds for different architectures for that version, dependencies. So any other packages that package depends on, etc., etc. And so Conda itself, it keeps track of these packages, which ones you've explicitly installed, and their versions, and also it manages installation and removal of those dependencies. Conda, the tool itself, it can search, install, remove, build, update packages, sort of standard sort of functionality you'd expect to manage any kind of software. Worth noting, there are things called meta packages. They are metadata only. So some groups of people like to, when they know there's a collection of packages that are needed to create a specific environment for their use, a project or an example, you can get people who create these meta packages, which just specifies all the packages, top level packages required, and installs the same way as a normal package. It just doesn't download a package, any software for that one. It just goes off and picks all the dependencies required. Channels. So this is another useful thing to know about Conda. There are different channels, and these are the different locations on the internet where you can download the packages from. So the common channel is Conda, the default one. If you that's the main repository of packages available via the anaconda.org website, which you can actually also, rather than just through the Conda tool, you can actually go on the browser and search for packages there as well. Bioconda is another popular one, and CondaForge is also another popular one. And CondaForge is quite useful. That is so where the Conda repository is managed by the anaconda.org organization themselves. CondaForge is community maintained, and it's quite good for having a more diverse range of packages than Conda. And as a tool, Conda allows you to manage those channels, add, remove them, set defaults. Also the order that Anaconda will search for dependencies and install packages. I've pulled this slide, is actually a screenshot of a very useful document, which is the cheat sheet for Conda, which is available on a Docs website, and it's a really nice, concise list of the main commands. I'm not going to go through them all individually, but just having a look there, you can see they're quite intuitive. If you want to install something, it's install, list, update, etc. Very, very easy to follow. Even I still use this reference myself. In fact, I might end up using it today myself. So that's a example of some of the commands there. Environments. So this is something that I don't think not everybody is aware of or use properly. Conda allows you to create separate environments which contain separate configurations of packages and dependencies. They are isolated, so as I mentioned earlier, you can actually use different versions of Python in each separate environment if you require. As a starting point, one environment per project is good. So to keep things nice and isolated, and when you are starting out with Conda, especially if you've got the full install, the base environment has a lot of packages. If you then add further packages to that that you require, Conda gradually gets slower and actually exponentially gets slower the more packages you install, because every time you want to install new packages, it evaluates all the installed packages, all the dependencies of the installed packages, all the dependencies of any packages you require before it will go off and download them. And that can take, even on a powerful machine, you can be sometimes waiting 10-15 minutes for that to happen. If you use Miniconda, separate environments, minutes at most. So that's one of the big reasons for doing that. You do get lots of minor issues if you overload the base environment, change some dependencies. With time, it's actually possible to get conflicting versions if you try and rebuild that environment. Something encountered last week with somebody who provided me an environment file that is not installable anymore, and when they have a list of 100 packages they've used, it was just impossible to go through and try and decipher where the specific conflict was and how to fix it. So yeah, it really helps if you can keep things as simple and small as possible in terms of environments. When you begin using Conda, you will have a default environment that's called base, and that contains the Conda tool itself, and on a mini Conda, basically just a few packages there to uncompress and actually manage dependencies. On a full install, it'll include a lot of things that like I mentioned, most people don't use. And I recommend you don't do much with the base environment if you can. I only use it personally for installing common tools. So if I use Git, which I know I use in nearly every other project, so I'll install that with base environment. But if I'm helping somebody out and we create an environment, I'll be creating an environment separately and putting NumPy and Pandas in that separate environment and not in the base. So I've just pulled off from the cheat sheet a selection of commands that you can use for using environments. And again, most of it's quite intuitive, but you usually have quite a few more flags to worry about when creating and managing environments. But again, it's using the Conda Docs website and this cheat sheet. It's quite easy to work out what you need to do, and we very rarely get questions from people in terms of support about actually using Conda in terms of what commands to do what. Now, environments YML should be all small case. This is a very useful, and I consider it a really important file for Conda. It defines it defines an environment name, the channels that want to use to resolve dependencies and install packages from, and the versions. And it is a lovely configuration file. I really recommend you start, if you know what packages you need, start off with an environment YML file and build that to define it, and then you can build the environment to use it by referencing the environment YML file from a command. Using that sort of discipline, it means you keep track of every library installed. You've got, in that one file, you can go to just to see what we've got installed, what versions. It's very, very useful. It's possible to export the current environment to a YML file. I don't recommend that because often it can get messy with lots of versions, lots of packages with a specific version, specific builds, which makes it extremely rigid. So when specifying versions, it's a really good tip is to only specify the versions of the top level libraries you want. Usually not even the point releases, but just the sub point releases, just the point releases, just so you know you're maintaining sort of API compatibility. Worth noting as well, two nice things about the environment YML. If Conda itself can't have the packages or doesn't have the dependencies, it's worth looking. It allows you to specify dependencies for pip, and that's useful for Python, as pip is probably the most popular sort of environments and dependency management package management tool for Python. And so you can use the environment YML to specify those, and when you create an environment or update an environment from the environment YML, it will actually go off and install from pip those dependencies in one go. So it's very nice. Another thing that's worth noting, the dependencies, the environment YML is stored separately from the location environment. I actually treat it as part of my code and store it alongside the code, put it in version controls, make it available there. So this is an example environment YML file. So it's a YAML format. So indentation and spaces is important for levels of hierarchy. In this case, I think it's quite clear. This environment can be called art.docs.-jb. It only uses the default channel, which in most cases will be the conda. We've specified some terms of dependencies. We've specified Python, Ginger, pip as specific versions, and below it JupyterBook. And JupyterBook's actually the main part of what we're trying to use in that environment. So quickly on to some best practices. As I mentioned, use Miniconda if possible. Try not to add packages to the base environment. At a minimum, stick to one environment for each project. Only try to sort of install the package you need for each project and each environment. If you want to experiment or do something different, it's very easy to create a separate environment and have a play with those. Even duplicate environments, install those packages there. And as I mentioned again, manually write your environment YML file because the export can create quite a restrictive list. Quick further reading: Anaconda open source, which refers to the freely downloadable version of Anaconda that we use. Miniconda is available from the docs. And I say the Conda docs website, Conda cheat sheet, Turingware, which is very nice for learning about reproducibility. And in terms of open research, a very long list to which actually gets cut off the screen. For what universities' official sort of documentation on open research, why we do it, and what areas of open research there are. So you've got everything from open software to open data to open publishing, and that website covers nicely all the areas of open research. So what I'm going to do now is I'm actually going to have a quick go at a live demo. I'm actually going to do it on this machine that's here. I've not pre-prepared anything. I'm not 100% sure this is going to work. So the only thing I have done is downloaded Miniconda already. I just want to check it'll work. So what I'm going to do is.
Are you doing a full screen share?
Yes, I'll do the full screen share, yeah. So this is just hopefully to show. So as you can see there, by default, it gives you an individual user install. No admin privileges needed. Yeah, leave the defaults there. This probably take about 1 or 2 minutes. So what I'm going to do is get Anaconda set up. I'm going to go onto ArtDocs website, which is where we use Conda ourselves. Go to the GitHub page from there, download the source code from Git, and then do a quick build and hopefully have a local example of the website in no more than 10 minutes. So let's see how it goes.
Are you for questions whilst that's doing that? Or
Yes, yeah. I mean, this is not a formal session, I think.
So challenge is probably too advanced, but a colleague of mine had developed something on Arc and exported it as you just warned against.
Yeah.
The YAML file for me, and I took that to be, of course, and you can't really quite easily use it there because they've got completely different chances because it's PowerPC, Power 9. So that was a challenge for me there, and I've got to the end of it, but just reinforcing your caution with the environment of YAML.
Yeah, so I think there's 2 issues there. One is the rigidity of the versions that was provided by the HPC system, but combined with its different architecture on Bead. So we know from history there is less libraries available on Conda in terms of packages, and so there's good chance.
My knowledge is about 12 months old, but I've just recently told they've done some revamp of this.
Yeah, but one of the things that does help is there are sometimes the dependency chains are different for different architectures because the libraries all might might already exist on the base operating system. So they're skipped over on Power 9, for example. So that's where just installing a top level defining the top level dependencies can make things easier. But yeah, Bead is different. It is gradually getting updated with more software, and people are using Conda itself more on those architectures. They are building and adding the packages to
Potentially, I
support
should
that.
have just taken a copy of the YAML and reduced the amount of complexity in it.
So what I've done certainly with Bead is when people give me a YAML file that's overly specific, because at its most specific, if you're these sort of examples, Nick gave, and it gives you like
15.
It gives you a particularly big thing, which is version 0.9.1. But the most specific is 0.9.1 dash and then a hash and an underscore and a number. And it means literally this build of that software. And I will not accept anything else. What I've done is load these YAML files up and done a search and replace and stripped off all the version requirements. And added back in by hand the minimum I know is needed. So if I know that you need PyTorch 1.10, I will put in a version requirement of 1.10 for PyTorch, but leave everything else as floating as possible, and then see if I can get that environment to build on Bead. Because someone like Bead, where you've got Power 9, there's a much smaller pool of packages available for Power 9 than there are for Intel, just because of how many have been built by the community.
Having the confidence just to go to nationwide, as you say.
Yeah.
Okay.
Just be all everything to people. Separate channels.
So there are some recommended channels for Bead. So they recommend things like OpenCE, but the number available now is significantly higher than when we first started to do. Because certainly when I started to Bead, it was very difficult to do some of the things our users wanted to on Bead. We found ourselves using SPAC. Now SPAC's a very different tool to Conda, because what's nice with Conda, what's quick with Conda, is it's only installing pre-built software. And so it's just blatting them out as a package management system. Tools like SPAC they've got a whole dependency chain, they've got a whole package system in a way that this has, but it's all from source. And so for Power 9, it's very useful to be able to build from source, because a lot of the software builds cleanly on Power 9. It's not that Power 9 is difficult to build from. It's just that it doesn't have the community of Conda Lab to have all those pre-built packages. So we end up doing a mix of Conda and SPAC, where you get everything you possibly can in Conda working, and then fill in the holes from a tool alongside.
So I have got the other one what you see where I don't have that. As soon as I do something from it, sometimes that requires compiling. And I can't compile it because I don't have quite the files installed.
Although one of the things that can work with Conda, but doesn't always, is obviously you can install compilers through Conda. Because Conda isn't just a Python or R tool, it's a generic management system. So you can install full compiler installs into Conda and then use pick and pick to find them and use them.
I just get over that.
Always feel free to get in touch with Research Review.
Sorry for
No, it's perfectly fine. This is what the session's for. Is to, it's to help people out. I'm not just
that was the thing I was going to ask about later on, maybe, but the idea that you have pip in there. I think it was important about where the occurs. Like you say, you might want to install a compiler before you try to further.
I think from memory, the pick step gets done after the Conda step.
Yes, that's right. Yeah.
As long as you install all the things that it needs in Conda packages, it should work.
So I've got working on Anaconda PowerShell prompt. It does include a command prompt as well in Windows. If you're using Linux or Mac, it will use the default terminal. So what I'm just going to do is, I don't need that many Conda website anymore. So this is the Art Docs, our website that we have our documentation for, mostly for HPC systems, but for various bits of software as well. This is the source for this is stored on GitHub. So what I'm going to do is just follow the link there to our repository. And what we do have, you can see the source files there, but below we have a nice README file. And again, this is a really good tip if you're if you're using projects, particularly on GitHub, a README file, quick summary of what you're doing, where things are, etc. 6 months later, you might forget. It's really good. So for like my case, I have that on my personal laptop, that one machine down there. I've got the ArtDocs website set up, which I did use using Conda, but it's been there for 6 months, and I know because the dependencies haven't changed, haven't touched conda commands directly for a long time. So I could scroll down and say, oh, right, it needs to do git clone. So what I could do is I'll go, oh, let's copy that. And what I can do is I could try running that now. And what do we think is going to happen? Hopefully it should say it can't find git. Yay! So what do I need to do? Oh, right. So let's have a look. So conda install. Yeah, tab complete on here. No, not Linux. Install git. So it looks so. There we go. So as you can see, the following it says the following will be downloaded. To install Git, it needs to update conda itself, LFNSSL for secure communication with servers where Git files can be stored on some certificate managers. Proceed, yeah, hit enter. Nice fast internet connection here. So download. Oh. Yes, so one thing we have noted is quite often when you're downloading, particularly downloading quite a lot of packages, it can just stop downloading. Could be solar flares to glitching your internet connection to anything, and generally just try again a few minutes later, 2 or 3 times, and quite often it will continue to download, possibly stop again, and we'll get there. So hopefully I've got Git installed. So if I press the up arrow to get back to that command, and I should be able to now take a copy of our source file. So it's getting quite big now. That's the only thing I find slightly disappointing about Git is you can't download partial repositories.
No,
yeah.
It's not the version.
So if I type dir, see that it's created at docs.github.io. So I shall go into that and then do a dir, not ls. And you can see three from the bottom, there's environment.yml. That is the same file. Hello.
So, and that install Git in the
Base environment, yes. So
if I have another environment active,
you can
install in whichever environment.
Yeah. Yes. Yeah. You can only have one.
Available in any new environment unless you tell it.
No.
No. So this is just in the base environment. Reason is because I need to download our source code, which has our environment file. And once we've got our environment file, I can then create an environment from that.
Conda does do lots of tricks to avoid excessive disk usage. So if you use the same package in more than one environment, it uses links between them. So if you do have a big package you install in several environments, you should.
The problem is that if you don't make a new environment, it's the same package.
Yes.
Yes.
And it won't be.
Yeah.
It's only specific versions that can be
Yeah. Unless, but you can update environments as well individually. So, which if you want to keep them, you can either go back and explicitly specify a version, and it will automatically update the dependencies in the package to that, or just do a general update and it will pull the latest. Just this is the environment YML file that is in the source code that I downloaded, just to show you what's there. Jupyter book is the main thing we're interested there. So if I go back onto here, onto our website, you can see git checkout working master. That's the default anyway, so I don't need to do that. And here's the command that I'm going to run: conda env create. That flag there, F means file, and that's going to the environment YML. So I shall copy that, and just paste that into there, hit enter, and it should now hopefully go off. Look at the dependencies it needs. Firstly, downloading the ones from conda, and then as John mentioned, it should do the pip ones afterwards. I think you have to explicitly install pip as well.
I think the newer versions of Python, pip is the default. So
yeah, right.
It comes in. I think old versions of Python didn't pip by default.
So as I say, yeah. So you can see it's going on.
Can we look at your YAML file with a text editor?
So what I'll do, I shall go on to.
Let's look at the website.
Oh yes, of course.
Oh yeah. No, well, John's. Where is it? There we go.
So that's it was that. Right.
That's it. Yeah.
Does it really mean 3.7?
I think from memory, there were extra cleanses added in there because we were finding inconsistencies between how it built the environment on Linux and on Windows.
Windows was the problematic version because there wasn't, I think JupyterBook, only a specific version of JupyterBook and Python combination would work at the time. I think now JupyterBook's better tested against Windows. We don't need that restriction anymore. But this was created. I'm trying to think, how long ago was this one? March. So yeah, that's so. I think since then things have changed. So we're getting there. But it's unfortunately doesn't show. Oh, look at that! Look at all those pip dependencies installed. That long list there. So quite a lot. So that's all the dependencies to get JupyterBook working. So
On none of those dependencies available on
some of them are, not all. That is why we had to go to pip. So some of the Sphinx packages, the base ones exist. So Sphinx is used to generate the HTML from Markdown. But some of the extensions that JupyterBook uses to generate its nice formatting don't.
It would probably be quicker to install if we worked out which was made for Yep, some of them are, not all, because we put the whole work. So in this case, I think the YAML is as neat as it could be, at the sacrifice of how long it takes to install, and we're quite laid back about doing more in this.
So that's quite simple. Yeah. If I look inside that, and let's say the Sphinx 1 for example, you had that not in the pip section, but added
it's
explicit content section. There.
Then it wouldn't install it by pip.
It wouldn't be on that list.
That version would be on it.
I think some of it as well is how the dependency chains build. The dependency chains are built. So if you've got a high level package in Conda, but you need some dependencies lower level, then actually if they don't exist in Conda, it's quite easy to specify that those lower level ones in pip. But if it's the other way around, so you've got Conda with a low level dependency, but the higher level ones in pip, it's best to ignore the low level one in Conda and just go straight to pip to do it all in one go.
packages where there is something called a Conda default and yeah, and we haven't quite worked out how the YAML file stop it from looking at default.
Choose channel, is it
Yeah.
prioritized?
It's strict about the channel.
I don't necessarily want everything to be prioritized. I just want that one package. Yeah,
I'm not sure you can do that with a single YAML file.
Okay. What I do is I install everything else and then type it on before it's installed.
You can formulate a command to do it, but I don't think you can do it in the environment file itself.
Case it all when you're sharing with a less computer literate person.
This is exactly.
Yeah.
It's trying to get students to recreate the environment.
It means you end up sharing a list of content parts rather than just a YAML file.
Yeah.
So this will work.
I feel I was being stupid.
No, I do it.
But if you can create that in a script file, that is, at least you've got that somewhere that's reproducible, and it's better than nothing. So if you have to resort to storing a series of commands to get your environment working, then that's what you have to do.
You could put the whole lot in the script files. Create the environment for you there.
Yeah, and end up with.
That's the other option, is it? Rather than dumping a YAML file, you can do it as zip files or something like that. Yeah, I think you get a text output that is slightly different to a YAML file, but it tells you everything that's in your environment.
Yes, you can.
More like requirements TXT, isn't it?
Yeah. Yeah.
That might be that.
I think there's also a way to get it to export effectively the Conda commands you use to build
I
the
think that's what I'm
environment.
looking for. Yeah, I can't remember.
So it doesn't pull in all the things that were pulled in as dependencies.
Sorry to everybody else on the call. Apologies.
No.
But yeah, I guess these sort of workshops are really, well, you guys can take away from this. This is something really useful to people. Yeah, just want to see that.
Yeah. So just to check this works, I'm going to try building our website. Look. Ooh, what's it do?
You haven't activated the environment.
Well, hey, you see, this is good thing about live demos.
That's
So
a good example of that. It shows you a Conda error.
And as pointed out, by installing it in another environment, not modified base. So base is left perfectly well alone.
Alright, so that's activated my environment, so hopefully I can now build.
And you can see your brackets at the edge showing you what your currently live environment is.
So this is kind of jumping out of Conda specific stuff, just shows that our environment's working.
If you're on Linux, all those horrible symbols would be nice colours.
Yeah, and if you're on Linux, it'd be finished by now as well. Sphinx is notoriously slow in Windows, but
Is there a way of bringing the environment from, say, Windows PowerShell? Can you do a Conda activate from Windows PowerShell?
That is a Windows parameter.
So Conda,
It's just wrapped by Conda.
yeah.
It
So,
just means it sets the parts and things.
Yeah.
But if you set your Windows PowerShell,
potentially, but Conda itself will basically set itself as a path that is used by PowerShell and command prompt. And if you open in Windows, if you open it has a specific configuration to load for each of these. How do you get to properties?
Probably not allowed on this.
Oh, that's a shame. But if you go into the properties, you'll see what they've done is they've wrapped the command prompt or PowerShell prompt around the Conda command to load the base environment.
But this Conda PowerShell is a proper PowerShell.
Okay. Yeah. If you're in Mac or Linux, it actually appends to the end of your bash RC or similar.
Yeah, usually says that.
Yeah.
That doesn't look like a PowerShell, that looks like a command. I know it says PowerShell at the top, but that looks like
I know it does, but it won't.
That's
so if you do a normal install of Anaconda on Windows, you actually get two links, one for opening.
Yeah, that's why I still use the full version where in the content to get PowerShell and not.
yeah. To be honest as well, if you use a PowerShell, it accepts commands anyway. So I think Conda's just kind of bootstrapping itself into there. So that's built. So if I now go into book, into build, new folder, we've got HTML. Let's double click on that. Look at that. So that's why we use Conda ourselves. Whilst talking to yourselves, we're able to download that, get an environment, working environment up and running quite, in just a handful of commands. So hopefully that convinces people that you should be using it if you can.
It really is running like.
Yeah.
So that. Yeah, I was thinking when I start off with a base environment with like minimum stuff, like 3.7, if I then want something very similar but build stuff, like you were talking about, building links. So if I clone that environment, that's sort of the sensible way to do that, so that you don't start getting logo.
So I have my personal copy of my cheat sheet here.
There's a few ways to do that. So you can just clone the environment and you've got
Is that genuinely replicating it?
Or
and I have, like, if I've got a 4 gig end here, and then say, well, I just want to do that, but I don't want to corrupt that one. I want to keep that one, but I want that one plus something else.
I think that's a sensible way to do it.
Yeah.
Use it clone.
So I could do a Conda.
Obviously, if you did it in quick succession, there'd be very little difference between read and environment download because the versions would change. So it would create one the same and it would share a lot. But if months have passed and you created it from the YAML file that didn't specify the version for it specifically, then you end up with totally new everything.
That's what I did. Yeah, well, no, I installed a new environment sort of 6 months later with the YAML without the specifications. Then I did it again about 6 months later when I was testing out a new version, and I ended up with a 30 gig installation of that problem because I had 50 packages in each environment and a different version of each environment.
You boot for the same one.
Yeah.
Well, but essentially the same environment but slightly different.
Okay, swear.
Yeah. Just an example. Just looked it up on my cheat sheet. Create flag, use clone, existing name that you want to clone from, and name for the new one you want to clone into. Hopefully,
So in
That-
Windows,
that-
you store these under the ES. You've got the
Yeah, CCC demo, yeah.
So is there actually a size? Can you like sort of file using Explorer than the directory folders the same size?
Okay,
that
that's,
not work like
yeah.
But I don't know how it is on the Windows. Certainly on the Linux, I believe it tries to use links to avoid.
Well, let's have a look. So go here. So Miniconda's where, and so that's the. So
that's all the benefits.
it's still running, so don't know how long this will take.
Sorry.
So what it's doing now, actually, so this is interesting, it's a long time since I've done a clone. It isn't just making a copy. What it's doing is it's actually done it as a transaction to make sure all the dependencies still installable and work, etc. So that's finished. So
There's
let
some database event.
So database event.
Keep track of that you mentioned.
well, the dependencies. There's some kind of database file or text file
I think it's all text file really. And every time you download a package, it keeps the compressed tarball of the package.
So as
to reinstall it, it's got that.
So that was my issue, was that it had a compressed tarball of about 10 different versions. Yeah. So that thing, all in one folder.
So
what have we got?
Not exactly the same. We've got 1 megabyte difference and about 100 and so files difference. But you've got to remember that each environment is not just the files that are installed, the libraries and software, but there's metadata as well. So that I don't know how the metadata's spread about, and that metadata will have the dependencies and listed and configurations. So let's have a
that come from within the event as well. You have an active.
Yeah.
So let's just have a look. I think the difference might be in the metadata folder. So that's that one for the new one that I created. And for the old one.
Or it might be that you running Python has generated some.
So if you can see there's a slight size difference just in the metadata itself there anyway.
You might find using that new environment to rebuild your duplicate might bring them back closer into line.
So let's give that a try.
You're not using that environment. They're still in art.
So what wants yeah. On the
There's a specific Anaconda leads question. Anaconda's on that center.
don't use it. Don't use it.
Yeah, but this is from a teaching point.
I know.
This is how we get told that.
Yeah, I agree with
But, I mean, this is. You also can't get the tool installed in the console, whichever desktop
So using tools like Anaconda in teaching is very problematic. Because of the fact that you don't have a consistent home directory. So you don't have you could install it into your drive, your space, which possibly you don't environment. And if you don't have that as an option, you have no consistent storage. But you can install it onto OneDrive. Not sure that would work well. I think the performance might be fairly poor, especially for students in the room. I think the main issue with using OneDrive would be the sheer number of files. So Anaconda generally, and I say this with my Lustre HPC panel, is deeply evil for how many files it creates. Because Lustre file systems are brilliant for big files and they're terrible for small files. And you look at this, and we've created an environment that really doesn't do a lot. We've got 21,000 files.
And the numbers haven't changed since building it either. So
what have you discovered, Nick?
I don't know the answer to that one.
Okay, fine.
I think some googling now. You've.
Yeah.
So not now.
One of the versions updated.
No, it didn't, because when you did the transaction, you saw it didn't download it. So I know we'll make the same way.
I did revert to Mobile X7 using Unix tools to get the folders. We are on the hour. Probably need to stop now, so I shall
pause the recording. Stop
Because of course
sharing.
the trade slides, won't be able to make it in tomorrow.
Unmute, start video. Woo! Share screen. This one?
Share everything and whatever you want to share.
I think screen is better. Probably I will change between things. Okay, so we do have one more. Hello there. So the idea of this code clinic was, come on. Okay, no problem. So the idea for this code clinic was give to the people answers for their own problems. But unfortunately, we didn't receive any questions. So this is a good opportunity. If you have any questions, we start with this. But if you don't have any questions, I will try to bring some questions and answer them together. Okay. So the first thing that I want to know is how much Python do you know? Come on. Yeah. Okay, so if I start to typing coding Python, we are going to be completely lost. Okay, amazing. This is good. So I will explain the things when I'm going. And you?
I've used it a lot, but for a very limited range of stuff. I do lots of numerical models. I've published a few Python packages, but they're all super restricted to very simplified libraries.
No problem, because today I'm going to try to use just the basic syntax without any packages or things like that, because this is the problem with Python. You can be very good at Python and someone shows you a package that you never saw before and I don't know how to use this. So let's try keep with the basic Python syntax and the basic functions, and let's see what happens. So I do have this problem that is called desirable number. I have no idea if this is a math proper definition or it's something just people from computational thing came up and say, oh, let's play with this, because to be honest, I tried to find this definition in a math book and I was not successful, but it's fun. The idea behind this desirable number is that you are going to use, let me see here, we do have a small dot here. So you can look at the number and we have the digit for the number. So here we have 8 and 0, so it's 2 digits, and we have the position of every number. So 8 is the first position, 0 is the second position. So if you get your digit and you power your digit with your position, and then you sum everything, we are going to come up with some kind of value. So 8 powered by 1 plus 0 powered by 2 is 8. But 8 is different from 80, so this is not a desirable number. But 89, for example, if you get 8 in the first position, so 8 powered by 1, and we sum this with 9 that is in the second position, so 9 powered by 2, so it's basically 8 powered by 8, 1, so this 8 powered by 1 is 8, this here is 8, 1. If you sum this, is 8, 9. So 8, 9 is equal to 8, 9. This is a desirable number. So this is basically the definition for this desirable number. So the challenge here is build a function that is going to return true or false for any number that you put. So you put an integer number, and we are going to receive a true or false as answer. So I will come here in my write code. I will open this in my Colab. This is publicly available. So if you go through arctraining.github.io, Python challenge here, you can find out this challenge and you can try by yourselves. Okay, so you can come here and write your code, and I need to remove this thing. So and then you can launch this thing in Vider or Collab. I'm going to open Collab because open faster, and then you can just type your code here without any installation, without any configuration, just doing your code. So okay, so how we can solve this problem? It's a question. Come on, guys.
You could get it to sum the number up and see what the result is, and then compare the sum result.
Okay, so let's start to write some ideas. So basically, we do need the digit, and we do need the position, because we need to do this kind of operation. And then we need to iterate over every digit in our number. So how we can iterate over every digit in our number? So let's give a n here. So I will call the function here. So I copy and copy again here. So I will call this for one, for example, 149. So how can I iterate over 149 up here? If I try to do, for example, if you do know something related with Python, we can use for loops to iterate over the things. So for example, for e in n, so we can do something. We can do, let's just print e for now. How is the problem with this presentation here? Let me increase the size of the screen a little bit. How is the problem with this definition? We are going to have an error here. Why? You can answer.
Oh, it's just an output 149. You're not good to know if that's the input or the output or what.
Sorry?
It's just going to print out 149. You're not going to know if that's the input or the output.
Do you think this is going to print 149?
No, it's going to print the position of each 1, 2, 3.
Do you think this is going to happen? Anyone has any idea? So let's print. Let's test. We need to sign in. Damn it. I do have an account, but I have no clue about my. Yeah. Anyone knows your own password? No. Okay. 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 Sorry, guys. I was not expecting this. So when he is trying to push his account, it's just in the Google account. I'm going to spoil the result for that program. It's going to raise an error because the number, the integer number, is not integerable. Okay, so we are trying to go through the number, but it's just a number. You cannot go digit by digit in a number. Five steps security. Your password has at least 8 characters, 5 numbers, 3 special characters. Ooh.
You have to read it again.
No problem. I can write again pretty fast here. So what we did before, we did a for e in n, and we print e. And then below here, I was calling the function, okay, with 145. Now we can say that we trust in this very good piece of software. The first try is going to spend some time because Google is turned on your virtual machine. So we do have an error. And as I said, the error is that integer numbers are not iterable. So what we need to do is transform this integer number here in something that can be interval? What are our options?
Arrays, characters, or string.
Okay, so we have an array or a list. Maybe here is easier, and a string. So what our colleague said was we could transform this number 1, 4, 5 in a list of number 1, 4, and 5. In that way, we could pass through every item in this list. Other option that I think it's easier to use is transform this in a string. So a string this, and now we can try again. So now we can go for every character inside that string, and we can iterate over, and then we can try to do something. Okay, we do have the number, so we can have the digit 1, the digit 4, the digit 5, but we still are missing the position. So how can I get the position here? One thing that a lot of people do in this situation is create some kind of count, some kind. We can start in 1 or 0, depend in the way that we want. So the first time that we pass through, we are going to print both the digit and our counter, okay? But the next time that we pass through this thing, I want my count to have a different value. So we can do this plus 1. So let's see what is going to happen. In this situation, now we do have both the digit that we were looking for and the position that we were looking for. Everyone is following up to here? Amazing. I will continue, and then I will come back and change things to be in my more Python way. But in the beginning, let's put the things in the way that we think, so it's easier to follow. So the next thing is make our operation. So we can came here with a total equals 0, for example, and we can have our operation here. So what was the operation? Was my number, my digit, powered by my count, but this needs to be after. So this is going to be at the end. This is going to work or not? What? Exactly. So we put our number, we transform our number in a string to transform this number in an interval object. So if you try to do this, it's not going to be possible because we cannot do this kind of operation with a string. We can try just to see an error. So this is not operated, supported operand type for string and integer. So basically what we need to do is come back this thing again for an integer. Now should work, the operation at least, but we also want to keep the value of this operation inside our total number. Okay, so at the end we can just maybe return our total. Maybe let's hope for the best. This is going to work. I think you should print something here. And I will hide this print. So let's see what we do have. Okay, so I'm just returning the total of your operation. So in this case, it is 142. Is this a Desarial number or not? No. Why? Because these two values should be equal for this guy here, be a Desarial number or not. Okay. The idea for this function is not returning the total value, is returning a true or false statement. So instead of returning this total thing here, I want to return true if both numbers are equal, or false if not. So we can do the following thing. We can do if if it's in the, sorry guys, this is after this thing outside the for. So it's when we finish the for loop, we can check if our total is equal or not. So if total is equal to n, we should have something like return true. Else,
for somebody who doesn't do Python, can you not do return total equal to n?
Yes. As I said, I'm going to first I'm structuring in the way that we think. So if this thing is true, I will return true. If not, I will return false. So now I will remove this returning total. We're not going to use this anymore. And now instead,
return false.
Ooh, it's wrong. Return. Okay, now should look better. Okay, now we instead have a number, we have the statement is true or is false. Okay, what was the example that I used before? 8989 should be true. So at least for these two numbers, we are good. Okay, so when we are doing, and this is not just for Python, this is for every problem that you have, we should come back. Okay, it's working. Okay, we solved the problem. We can go home now. But I will say to you, no, let's think a little bit more about this, because I think a good approach here is come back and try to structure things in a more computational way and less in a human way of thinking. And we can do this using the things that Python can offer us. And before I move on, I will say to you that it is possible to solve this problem in just one line. Okay, so in the moment we are using, I'm not going to counting, but we are using this amount of line. Okay, so it is possible to use just one line. I don't recommend to do this in one line because it's going to be very difficult to understand what the code is doing, but at the same time, it's a good challenge. I always think, oh, how can I make this more concise? How I can use just one line or two lines. So if we have a problem with a bunch of if and else or a bunch of for loops, we always can think how we can reduce the number of ifs. This kind of thing here is not a good thing in a code. If and else statements are not good things in code. They are necessary, but they spend a amount of research to run. So the idea now is come back and trying to figure out where we could do better. So the first thing is our colleague already said we could just return this thing here, instead use this if and else statement. Because when we do total equal n, what we are going to get is a true or false. It's just that. So basically we are doing if true, return true, if false, return false, when we can do just return total equal n. We could do just that to replace all these four lines. Okay, so let's do this and let's see what we get. Every time that you make some kind of change, check again if it's working. But now I'm going to move on a little bit. We are just testing for one number. Maybe it's working for this number, but it's not working for other numbers. So it's a good approach to have some kind of test unit. And I do have one here. So for every challenge in that page that I showed to you, there is a space to you put your code, and there is a test unit to test your code. So here we are going to see if our result has the right type as the answer. We are going to test if works for a true value. We are going to test if it works for a false value. So we can test with different things. So let's run here, and we can see that works for the three things that we had here. So I have a colleague that did the same problem, and he was returning true and false, but as strings, not as Booleans variables. And he was, it's right, it's returning true or false. What is not working? And I say, you should read first the rules of the problem. So I'm giving instructions what should be done. And you also should look your error. So look your error and figure out what is wrong. Okay. So two other things that we can do here, very simple to work in a more Python way. So Python does have a operator to do this kind of situation. So when you want to add a value inside a variable that already has a value, we can use this full statement here, or we can just add a plus sign, and remove the name of the variable. So this is pretty much the same thing that we had before. So we are starting to clean up our code, okay? And why this is good in the way that we are doing. So if you remember, when I used the if-else statement, I forgot, was intentional. Yeah, was not. But I forgot a return. I put just the false, and this gave me an error. So if you do have unnecessary lines, there is more chance for us to have silly mistakes or silly errors in the between. So if you build a very clean code, we reduce our chances of having silly errors. And if you do have an error, it's easy to spot where the error is. Okay. So this is good. Let's see if it's right. Sometimes I put this plus sign in the wrong side. Instead of make plus in equal, I put equal and plus. So as I said, every time you made a change, be sure of testing. I did not test, I just run the function. The right thing is running the test and see if everything is okay. Let's move on. How we could do this even better?
We are pull the casts out of the loop, so create a string and an integer outside the for loop.
I'm not sure if I understood your idea.
So instead of converting n to a string in the for bit,
okay,
create a string calls before that, and then just call the.
You see, just create another variable using this string n.
And the int as well, because each time you do a cast in the loop, it's inefficient.
Yeah. So this is a way of making the code more efficient. So it's an idea.
It makes it a little bit more precise in the loop. What's actually.
Okay, so I'm not sure if I figure out what you're saying, but you're saying to create some kind of string n equal to string n, and here just call the variable.
Yeah, that's it, and then the same for the inside as well. I can't do that actually.
Yeah, this is not.
Honestly, that's a bit neat.
I'm not sure that would make any difference with it.
Okay, so we have a fight. Okay, so how we can define if it's good or not? So we do have a change, but we don't have any idea if it's good or not.
run it and time it.
Okay, so what is the best way of using this thing? So I will compile this code and I will create another line of code, and it's time it. The name of the function, I'm not very sure how. Need to do this?
Yeah. Give it a number. You need to run it. You need to do something.
We need to give a number. Okay, so if you are not following, TimeIt is a Python package to give you an idea about how much time your coding is spending. And if you do some kind of change, you can test again and see if this change makes your code faster or not. I don't like this kind of thing because you usually have this is lowest. So I think if you do this, no, let's use in the other way. So okay, let's try again. So we are going to. There is a small detail here. So the computer is not going to work exactly the same every time. So if you run this function again and again and again, you are going to probably came up with slightly different results. But let's think here. So we have a best resulting taking 1.5 microseconds. Okay. So what we are going to do, we are going to return for what we had before, and we are going to see if this was better or not. So as you can see, there is no one way of doing things. People thinking differently, people have different ideas, and sometimes we just need to try. So let's try another. I think it's going to be so close that is going to be impossible to say what is better or not. Exactly the same thing. Okay, so now we can decide. It's exactly the same thing. What do you prefer? You prefer including one additional line in your solution, or just keep with one clean solution? This is totally personal. So if you think this additional line is going to make easier to understand your code, use the additional line. If you think it's not necessary, don't do it. So just use. So you had an idea before, so.
Yeah, so before you speak enumerate.
Yeah, so this is the best solution. So the problem with the construction that we have is that we are just have the item inside our list. It's not a list, it's a string, so we are just getting the character of the string. But Python has a enumerate. Python has a enumerate thing. If I'm not wrong, I'm wrong. It's with E, and now it's right. So this thing is going to return your digit, your item in the list, and is going to return the position. Okay, so we do have two options here. Before doing anything, I'm just going to print what we are going to get. I'm just missing something here. I'm going to fix. As we are going to return two things. We need two things here too. So now it's right. I'm going to just print out what do you have. So as you can see, we are using the 8, 9, and we are receiving 0 for 8 and 1 for 9. So basically, we are receiving I is the counter and J is the digit. Okay. The major problem here is Python start with 0. We do have two options. We can just choose print I plus 1. This is going to solve our problem. But I think enumerate accepts one thing like, yeah, accept. So we can force the enumerate start with 1. So now we do have 1 as position for 8 and 2 as position for 9. So let's put some kind of thing. Let's put this position, because it's difficult to understand what is Y and J. So let's move in this, and this is the item. Or in our case, let's use the digit, okay? So our operation is going to be integer digit powered by the position. And we don't need the count anymore because enumerate is giving us the count. So we can remove this line and we can remove this line too. So we remove a lot of things. We cleaned a bunch of things just by doing this. And I hope I did not wrong. Let me remove this empty line because makes easy to see the result. So this is true for 8, 9. I think it's right. And let's see, what do you have here on the test with, okay. Oh, and we can even try if we have something better than 1.25. So let's see. Make our code clean was easier to follow, but was not fast. This can be 2 things. First, it can just be a fluctuation of your computer. We can try again. Or sometimes we just choose. It's sometimes just the readable way, or the readable choice is not the fastest choice. So it's always what we do have again a 1.5 instead 1.2. Okay. So
as well as building commands like enumerate don't just do enumeration of a number. They work on different types. Yeah. So they've got to have the logic into working.
Yeah, yeah. It's another function running there. So
you're assigning 2 variables each time you go through.
Yeah, yeah. So sometimes you do need a faster code, and you should choose work with the faster thing. But sometimes, what is the difference for us between 1.2 microseconds and 1.5 microseconds? It's not going to make any difference in this example. So we can choose the one that we think is better or not. So it's just to show you that there are different ways. There is no right answer, depends on what you are looking for. And the idea is just building a structure for us to solve some kind of problems. And now how we can put this in just one line?
We're getting rid of operations.
Yeah, you can get rid of operation. We can just remove at least one line. We already removed it, so we can doing this kind of thing. So we can remove operation. It's still running. Let's see our test, unit test is still okay. So everything okay for now. So we do have 1, 2, 3, 4 lines. Same logic also. Are you familiar with list comprehension? No? Yeah? Okay, so I had some no's and some yes. So I will do here a basic explanation about list comprehension. So Python does have a special way of building lists. So note that we are not using lists here. So probably this solution is going to be even slow than this one. So, but it's just to see that it's possible to do. So Python can build a list. using for loops or using list comprehension. So I will do a simple list using a for loop so you can see and understand how I am building the list, and then I'm going to change it using list comprehension. So let's going to start with simple list. And I'm going to create this list empty, okay? And then I'm going to iterate for I in range, for example, 10, okay? And then I'm going, for every time that I go up, I pass through this for loop, I will add I to my list. So I can just do simple list dot append. So I'm including a new item in my list, and I will include this I. So at the end, I will pass through 10 times, and I will add 10 elements to my list. And at the end, I want just to print my simple, I hate these things, simple list. Okay, and we can print. So very simple. I create an empty list. I use a for loop to every time that I pass through, I iterate the for loop, I add a new thing inside my list. Okay. So this is a way to go. Sorry, the other way to go, I'm going to do the same thing here, is using the list comprehension syntax. So the list comprehension syntax is square brackets. You are going to use your operation here. Then you are going to determine your for loop here. Okay. Basically that. If you have some kind of if statement, you can even put your if statement here. Okay. I'm not writing everything. So this is basically the idea. If you can write your operation in your for loop, you can do this in that way. What you don't need here is the append, because every time that you pass through your loop here, the list comprehension knows that the idea is adding something into your list. So I'm going to do something just slightly different. I will multiply my integer by 2 here, just to you understand what is the operation. So we do have a list where every item in this list were made by one operation of I times 2. Okay, so what I want here is a simple list. And this simple list is going to be building by an operation of I times 2. And now I'm going to determine my loop here. So my loop is going to be I in range 10. Okay, so I'm writing here pretty much the same thing that I write here, but in a different structure. And if I put, I need to print. If I didn't print, we are not going to see anything. So if you print here in one line, we did pretty much the same thing that we did here in 3 lines. And using this concept, we can reduce a lot of different problems in just one line. So let's suppose that we want to get the sum of all these values here, how we can do this in this situation, because I think this is going to return an error here. No, it worked. Okay, so it's perfect. So you see that we can return the sum just putting a sum in the front. So if you want a sum of this value in the first one, you should do something like sum equals 0. And then every time that we pass through here, we do have a list here, so we could do the same thing. Sorry, my mistake, no problem. Okay, so let's try to use this idea in this solution. I'm going to create a code line here. It's difficult to see. Okay, press here. Oh, much better. Okay, so we do have our function. I'm going to copy the function. and we want return. We are going to return. Okay, we want to. This is the thing that we want to return. The idea here is that we want to create this total using this this construction. So create a list with a list comprehension and sum everything. So let's first using a new line here, and then we put everything in one line. So our operation is int digit powered by position. So this is our operation. I'm going to put this inside square brackets, and then we need our for loop, and our for loop is this thing here. This is our total. So I want to replace this thing here inside the total, and I hope this works. Oh, it's not going to work because we don't have the sum yet. So we do have the sum. This is here. So in one line, very ugly. It's impossible to understand what was done, but it was one line solution. Let's see if it's working. Let's now test. Oh, it's working. So we came up with, I don't know how much lines we had on the beginning, 10, 15, I don't remember. I don't think this is a good solution. It's difficult to see. It's difficult to understand. Probably it's not fast because transform your problem that was basically integers numbers in a list.
Can we see how fast it is?
Can we see? So we start with this time here. I'm trying to make things better, and I'm not, I know. We increased for 1.5, and now it's going to be much worse. But let's see what happens.
With a list comprehension,
oh, it was not so bad.
Can you convert all the values in the list from in one go, or do you have to do it one by one as you go in? I don't think it might work in this situation, but can you convert a list of ints to a list of strings?
Okay, so we do have the list comprehension. What do you want?
Can you convert a list of ints to a list of strings in one go? I've not used this company.
Yeah, I think it's possible because the whole idea behind the list comprehension is building a list based in another list. So you do need at least one list to start. But if you do have more than one list and a string can be understood as a list because it's interval, you can go and transform your list in another thing. So here we are using the range list. It's not a list, it's a range object, but it's like a list to build our simple list thing. So it's always using a list to convert to another. So, yeah. We still have 10 minutes to go, but I think we did everything was possible with this simple problem. So now is your turn. Do you have any comments, questions, or anything else? Please.
I was always taught when I was programming that like debugging is much harder than writing software in the first place. So if you think you're being clever when you're writing software, you just create something you have no hope of debugging. It's you know, obviously you sort of said this, but the trap of this sort of solution is you spend all your clever on the solution and you create something that will completely defeat you in the future.
Yeah.
How do you balance this sort of code tightness with readability and usability?
I think in a long way, readability is more important than anything. So if you need to spend more lines to make things easier to understand, please do, because in the long run, you are going to be happy for doing this.
As well, trying to do things in the way that is documented as the most standard way for a language to generate text, because you more like to find matching examples and if something's wrong, I like to get help because people.
Yeah. If you do things in a standard way, it's easier to follow up what you did. So it's easier to find any material to help you to understand and so
Well, that's
on.
not always easy because even in Python, there's quite often 2 or 3 ways to do the same thing.
Yeah. No, we just need to start to think that we are using logic to solve problems. This is beyond Python. And I think in one way, you think in another way, and she think in another way, and so on. So people think in different ways. So people are going to build things in different way, even using the same tools. So
what I always try to just write it how I think it, so that when I come back to it in 6 months, I've written down what I thought 6 months ago.
Yeah. So as I said, it was what we did in the beginning. So the only problem with that is that sometimes if you just follow our way of thinking, we cannot solve the problem.
Yeah.
Because I think the most important thing for the computer is that the computer can do a lot of operations at the same time, and we cannot. So if you think, for example, in an astronomical problem, we can calculate the force between 2 planets, but we cannot do this by hand for a bunch of planets and asteroids, stars, and so on. So we do need to have this computational way of thinking to take advantage from the computer. So just to finalize, my idea behind this section, we built the first solution using the most human way of thinking. I'm not saying that when you are solving your problems, you should reduce everything in one line, ugly and difficult to understand, and sometimes even not is lonely. So I'm not saying you to do this, but doing this kind of small challenge of how I can use this kind, how I can change this, how I can make this in one line, or how I can improve these things, is more to create some kind of new logic for you. So at some point, if you need some different way of solving something, you already had this training before of how to think in things. So it's not about building this thing in one line, but it's knowing that you can if at some point you need. And there is no easy answer. You need to figure out the right balance between what is good, what is better, if it's having 1 microsecond less when you're running, or 5 lines more to make easier to understand your code. So,
but if it is that good for the computer, then just have it out with comments, it'll be fine.
You do everything in 1 line and spend 50 lines in comments explaining what that 1 line does. Yes,
and
perfect.
Also, other thing as well is how long it takes you to write it versus how better it's going to run. You could spend 10 hours just for a small game. That's run an HPC system in 5 seconds. It's not worth doing.
This is my life mistake. So I always spend 10 hours doing something that is going to run in 10 seconds, and then I spend 10 hours doing nothing. It was not necessary. But so, yeah, it's always a balance between what is necessary and important. So, yeah. So just to finish, everything that we did today is, I'm going to leave this. Oh, it's necessary to log out. Okay, so I'm going to come back to this just a second here. So I put together some materials for Python challenge. If you want to do things similar we did today, I have here a list of some problems. They are small problems that you can play the time that you want. So you could solve in 5 minutes. We spend an hour talking about, but is the way. So you can go arctraining.github.io and Python challenges. Okay.
Thank you.
Anything else?
Okay, what are your plans for developing it further so that you have play with numbers and then you have another play with random numbers?
Oh,
it looks like you want to develop this.
Yeah. Yeah, so I'm working with the Fleet City students, and they are having problem to transform what they learn because they learn a programming language, and they are having problems to use this to solve their own problems. So basically, I know how to coding, but I don't know how to coding. It's basically this idea. So I'm trying to building this logic behind. So playing with numbers just to hit up. So this is small things. The random numbers is to take advantage that your computer can do a lot of operations. So we are, for example, here we have rolling a dice and tossing coins. So we can solve this analytically because we learned this. But the idea is, if you don't know anything about combinatorial analysis, how to solve this thing. So you can just run tossing coins several times, a million of times, and see the probability of things happen. So it's using the computer way of thinking. And to be honest, I'm not sure about the next steps. Probably going to arrays because they are very important. If we add dimensions in arrays, becomes very difficult to thinking about. So people have difficulty with what is the line, what is the column, and so on. So probably I'm going to follow this. But as you asked, in the first page introduction about everything here, we do have a challenge proposal. So if you have any specific idea, or if you have a comment or anything, you can come here and fill the form, and I will consider it to put in the material in the future. Maybe I can run this thing for the entire university. At least is my plan at some point. Okay. Anything else? Okay, so let's go home.
Thank you very much. Good.
See you tomorrow.
Yeah. I think there's a bit of a social event after this.
I will have a social event with my bed. Sorry, guys.
Yeah,
I'm old. So we need to
Stop sharing.
stop sharing.
Stop the video.
Stop the video.